Hello grade 12s, welcome to my channel, and today we're going to be discussing this paper from November 2015. It was by request, and that someone who requested this video actually called me by a name I do not really tell people and actually only my mother called me by my name, by that name. So yeah, anyway, that kind of made me melt a bit. So yeah, I kind of melted a little bit. Anyway, I'm sure you got something on this paper. It looks very interesting. So instructions are very important, and essentially commit these two to memory, although you're not going to ignore the other instructions. Okay, so let's get to it. Question 1. So we know in question 1 we're dealing with quadratics in different formats, and then of course they can add some spices somewhere somehow. Okay, so we've got 1.1.1. so this is x squared minus 9x plus 20 is equal to 0. Always attempt to factorize if you can. The only way you can check if this thing is factorizable, just check the discriminant, b squared minus 4ac. And if the discriminant is equal to a perfect square, for example, if the discriminant is a perfect square, then it means you can factorize. Otherwise, if it is not a perfect square, even if it's positive, it means the roots are irrational, so you may not be able to factorize. So you can think about it that way before you waste so much time attempting to factorize. And then here we've got 20, and the numbers that multiply to 20 but add up to 9 is 5 and 4. Of course, these two are both negative. Therefore, x is equal to 4 or x is equal to 5. Now, please check these solutions against the original equation. So we check these in case we made a mistake with some sign somewhere. Then of course, if you put a 4 in there, we get a 0. So this means this is a solution, and that is also a solution. So the factorization is the extra mark. Okay. 1.1.2. We are given 3x squared plus 5x equals 4. And then of course this is a quadratic, so we need to put it in standard format before we can do anything with it. We transpose the 4. Now that is in standard format because we have a as the coefficient of x squared. We've got 5 as the b value, and we've got minus 4 as the c value. Again, when we check the discriminant, obviously the clue here is correct to 2 decimal places, but at times they may just keep quiet and you have to decide. So if you check the discriminant here, it's not a perfect square. So this means we're going to use either factorization by completing the square or the general quadratic formula, which both techniques is one and the same thing actually. It is just something that is looked at differently. But they amount, in fact, they are interchangeable if you think about them. So this is going to be minus into 5 plus or minus. We've got the square root of 5 squared minus 4 into 3 into minus 4. All of this is divided by 2 into 3. Therefore, our x is, you can clean it up if you want, but for the sake of time, I am not cleaning anything up, okay? I'm just moving along. So 5 squared minus 4 into 3 into minus 4 divided by 2 into 3. So here, please guys, make sure you are meticulous on the substitutions, because that is essentially what decides if you're moving through or you're messing up, okay? So the next solution here is minus 2, 2, 6. Okay, so that's what we've got. Again, folks, don't be excited you just completed the task. Check these solutions against the original. Obviously, this is a whole number, right? So that means here we're going to have to round off to the nearest integer. So let's see what happens when we put a 3 into 0.59. You square that plus 5 into 0.59. So I'm getting 3.99. So rounded off to the nearest is a 4. So it means this is acceptable. So you can check the other one to make sure that you are not dealing with coincidences. And then of course the correct substitution there. Getting how many marks? 4. Probably writing this in standard format. Remember, this is algebra, so most of the algebraic techniques are actually being tested. So 1.1.3. How? We are at the bottom. Here when? That means I just started in the middle somewhere. Okay, now I'm wasting time. Let's move on. So we've got 2 times x to the exponent minus 5 over 3 is equal to 64. So the first thing we want to do here, we divide by 2 throughout, okay, such that we get x to the exponent minus 5 over 3 is equal to 64 by 2 is 32, okay. This implies, now we can express this as essentially x to the minus 1 over 3 all to the exponent 5. I'm just playing with the exponential rules here. So this is the same as 2 to the exponent 5, is it not so? Yes. Now we've got the same exponents, that means we can actually equate the bases. This implies, maybe it's going to mess up a bit. This implies that x to the exponent minus a third is equal to 2. Okay, great. So now what do? We need to perform a gymnastic. We want to eliminate that minus a third. I mean, there's plenty of ways. You can actually do a gymnastic here where you multiply the exponents by its positive inverse or reciprocal, which is, let's just say inverse. It's going to be minus 3. Not actually inverse, but we want to get rid of that. And then whatever you do there, you do here. Or what we can do, let's just do it this way so that we don't struggle at all. So that multiplied by that, it leaves us x is equal to, now this one is basically 1 over 2 cubed. Right, we're writing it as a positive exponent. Therefore, our x is 1 over 8. Nice and easy. Okay, so this is how we solve this. Obviously attempting to do it without using a calculator, or you can introduce logs here and use your calculator. You should pretty much get to the same answer. So can you see this is a spice to this kind of questioning? So let's see, 4 marks. I guess this is important. And essentially, this gymnastic, it's an algebraic technique, is important. And to essentially write this as a positive exponent is also important. And the answer. So this is essentially most likely the way of how we get those marks. Okay. 1.1.4. So we've got the square root of 2 minus x is equal to x minus 2. Alright, so this implies we repeat this so that we can work on it. So at this step, we do inverse operations to try and get rid of the square root sign. So this becomes 2 minus x equals x squared minus 4x plus 4. Okay, we move things around to this side and rearrange. We get x squared minus 4x plus x is going to be minus 3x. Transpose the 2 is going to be plus 2 is equal to 0. Okay. So that is the story. That is the story. Essentially, what do we do now? Attempt to factorize. So factorization is a technique we need to understand and learn very well. Otherwise, it becomes a very difficult situation. Therefore, our x is a 1 or our x is a 2. So now we've got to check our solutions against the original. So what are we checking against the original? Two things. One, the left hand side has to equal the right hand side. That's the main check, essentially. But there's a second one that we need to consider. Once we've got surds or square root signs or radicals, we must never have a negative under the square root sign. So it is not allowed. We must not have a negative under the square root sign. So that is what we need to double check there. When you put a 1, it's 2 minus 1, which is 1. Square root of 1 is 1. Remember, this is a positive square root. It's not a negative. So we accept it as a positive square root. And then here we put a 1. It's going to be 1 minus 2. So this one says this one says 1 is equal to minus 1. And that is not making the left hand side equal the right hand side. 2, it's going to be 0. Square root of 0 is 0. This 2 minus 2 is 0. So this one goes. So rejecting that solution is important and accepting this one is important. Getting this quadratic is important, and essentially performing those gymnastics is important because we are doing algebra here. So everything that you do is mark worthy essentially. Okay, so that's it. So 1.1.5. We've got x squared plus 7x is less than 0. Now, what do we do here? Obviously, we attempt to solve. So we take out the highest common factor. It's going to be x plus 7 is equal to, is less than 0. This is our attempt at finding what we call critical values, which is actually intercepts of this graph. Now, we take our values against our algebraic table. I'm doing this as often as I can so that you guys can learn how to do this. It is very important. It can save you when you get to functions. When you get those very high order questions for no marks at all, but you have to account for some things, okay? Alright, so the critical values, when we solve here, we get 0 and -7. So always put them in ascending order. Yo, looks like we're going to have a hailstorm tonight. Anyway, we ask ourselves, when will this x term here give us a 0? Obviously, when x is equal to 0. When we put a value greater than 0, that becomes positive. When we put a value less than 0, that already becomes negative, negative, and negative there. And then we come to this one. When is the next binomial factor going to give us a 0? When x is a -7, right? -7 plus 7 is 0. When we put a value between -7 and 1, let's take -2 for convenience. This becomes positive. When we put 0 in there, we still have a positive answer. When we put a value greater than 0, it still remains positive. Automatically, that side should be negative. But you can check in case you're making a mistake. Now, this is the part that reads our solutions. Now, we're doing a multiplication in that bracket. So we essentially are taking a sign of that particular situation and multiplying it to this next one. And when we say minus times minus is a plus, minus times 0 is 0, minus times a plus is a negative, 0 multiplied by any number is 0, a plus multiplied by a plus is plus. Now, our solutions, we are saying we want this to be less than 0. So when is this product less than 0? In between these critical values. So here we just do that. That is where our solutions lie, since these are not included. Therefore, we can say safely x is less than 0, but greater than -7. And that is our solution. Okay? At this point, I would like to show you another technique. I will just summarize it quickly. So quickly, what we can learn here is that from the original function, we can see there's an invisible 1 there. That says the coefficient of x squared is positive, meaning a is greater than 0. That gives us a smiling parabola, a shape, okay? Those critical values give us the x-intercepts. Now, what do we learn from this? We are asking ourselves, when is this graph below the x-axis, or meaning, when are the y values on the negative y-axis? And we can see that that area between these two critical values or x-intercepts, every x value in that region gives us a negative y value. And that is essentially that same conclusion. Okay, so usually we get 2 marks for this format, and probably for the technique that we chose, or the critical values, it doesn't matter. Or you can choose that. Okay, let's do 1.2. 1.2, we are given this equation here, and we are told solve for x and y. Now, when we inspect this, if these two are equal to 0 and we've got terms, this means both of these have to be 0 for us to get a 0. Otherwise, there would be no 0. Okay? So, this 3x minus y all squared plus x minus 5 all squared is equal to 0. For this to happen, it is suggesting that essentially we can start with this one. It means x minus 5 all squared is equal to 0, and this 3x minus y all squared is equal to 0 as well. The reason for the and is because both of them have to be 0. Okay, which implies when we solve this one, we essentially take the square root on both sides. We know that x minus 5 is going to be 0. Remember, for 0, you can't say plus or minus 0. 0 is just 0. So here x is going to be 5. Okay, and then we get to this one. Now that we know what x is, we essentially are going to substitute x. It's going to be 3 times 5 minus y all squared equal to 0. Take a square root, we're going to have 15 minus y is equal to 0, because we can't have a plus minus 0. Therefore y, when we transpose y to that side and then rearrange, is 15. So now, are these solutions valid? We can put them into the original. Again, please, it's easy to make mistakes here. Do this exercise because you are guaranteed marks here. If you check this out and they are correct, that means you are scoring those marks. So let's put x for 3, that's 15 already. Y is 15, that gives us a 0. So they check out for the first one, and then we put a 5 in there, we still get a 0. So for me, it says we have done justice to this question, essentially. So that is the two solutions, and essentially equating each one of those two terms to 0 is important. So this is how we score those 4 marks. This question could scare you off and make you think you're going to break your neck, but you're not. It's just logic. 1.3. Okay. Now 1.3 says, for which value of k will this equation have no real roots? Okay. So this question is a smart question, to be honest. Let me show you why I'm saying that. If, for example, we're looking at x squared plus x is equal to k, it means we've got two functions that are equal to each other. This is a parabola. It's a smiling parabola. So let's say this is what we've got over there. Now, a smiling parabola, remember this one passes through the origin because there's no constant term. And obviously, b is positive. Remember, when we want the x-coordinate at the turning point is minus b over 2a. So it means the turning point is going to be to the left, like that. So this is how our graph is going to look of the parabola. But k is some constant, meaning it's a straight line graph. Now, for this not to have any roots, meaning it can't be here, because roots are the points of contact. So meaning it has to be below the level of the turning point. Because when it is below the level of that turning point, let me just extend. Can you see there? This is where k is. So meaning this line is y is equal to k. So can you see when this function here, k, which is a straight line graph, a horizontal line, is below the minimum value of our turning point. The minimum value is what we need to interrogate. What should it be? We've got a full equation. So the minimum value is when we substitute a half here, minus a half. So let's see, because we know that x at the turning point is minus b over 2a. This is minus into 1 over 2 into 1. So this gives us a half, minus a half. That means the y value is going to be f of minus a half, which is going to be minus a half squared plus into minus a half. Okay, so that squared is 0.25. 0.25 minus this one, it leaves us minus 0.25, which is minus a quarter. So we've got minus a quarter here as our minimum value of our graph. So what does that mean? It means our k value has to be a value less than that for these two not to intersect. Otherwise, if it were to be here, you can see that from this point they touch, so they will have a point of contact. That would be a root, a single root. Beyond that, they keep having 2 real roots. So let's just remove that one. So you can look at it graphically and then write an answer that basically k must be less than minus a quarter. That means you can just draw the graphs here as part of the solution and essentially indicate the minimum value at the turning point and technically then make the conclusion, because that would be the answer. So there's plenty of ways of solving this, but let's solve it algebraically because we are still doing question 1. So we've got x squared plus x is equal to k. So we can see this is a quadratic, but we can make it in standard format. So this is x squared plus x, we transpose k, we put it there, it becomes 0. Now, what is the story here? We can see that now we've set it up in standard format. So there's an invisible one there. There is also another invisible one here. And this becomes basically A, B, and we've got C as our constant. So now we are actually making this into a composite function. Now we want to ask ourselves, if we're saying no real roots, for this situation it has to be something like that. Graphically, I'm just giving you extras now so that you can understand. Now essentially, depending on the value of k, we don't know what the value of k is, but we are suggesting that now this graph must have no real roots. So what does that mean? It means this graph should not touch the x-axis. It can be something like that. Why do I know it's supposed to be like that? Because the coefficient of x squared is positive, meaning it's a parabola that is smiling. Otherwise, one would entertain a grumpy face, but still not touching the x-axis, but that one is out. So this means, what is this minimum value for this graph not to touch the x-axis so that we can find this? We can see that k must be a positive value, but whatever that value is, it's very difficult to tell at this point. But we know that this is the shape that we are talking about when we are saying there mustn't be any real roots. Okay, so let's work it out now. What would be these values? We can say for non-real roots, it is such that the discriminant must be less than 0, is it not? Because it means we can't solve. This implies that b squared minus 4ac must be less than 0, which implies what is b? It's 1 squared minus 4 into 1 into minus k, less than 0. And then what do we have here? This implies that we've got 1 minus, this is going to be minus 4 times minus k is going to be plus 4k, less than 0. And therefore, when we solve for k here, k is going to be less than minus a quarter. So this is what the story is saying. So can you see algebraically it comes out as well nicely? Okay, that's all right. Now graphically, as we wanted to use the graph, there's a technique that we can apply here, which is what we complete a square. So when we complete a square, what happens? I just want to show you techniques upon another so that these questions do not ever give you troubles, because they have a way of dictating how you should solve sometimes. Now when you complete a square on this, we know that for x squared plus x minus k is equal to 0. When we complete a square, we take the x term, we take the original sign between the two x terms, and then we take half of that we then square, and then we have our constant, and then we immediately subtract a half squared. Equal to 0. So this means we've got x plus a half all squared minus, now this is going to be minus k minus a quarter equal to 0. So what is the question now? Remember, the turning point, which is the minimum value that we're looking for, is going to be given by the negative sign of that is going to be minus a half, and essentially I didn't forget brackets, so this one is 2, then this value minus k minus a quarter. So that is our turning point. So from completing a square, we learn what the minimum value would be, which is this one. And we are saying the minimum value must be a value greater than 0. So you just solve at the last portion algebraically. You are saying k must be a quarter. This must be greater than 0. Right? Because that graph, this is working together with that graph. As you can see, for that situation to occur, maybe let's put it nicely. Let's put it nicely. It's not so nice the way it looks. So this graph, we are suggesting that wherever it turns, it's doing things like this. And we want to know that minimum value. What is that minimum value right there? And essentially we are saying that minimum value, whatever it is, we don't care. It has to be a value greater than 0, because if that's the case, it means this graph will never touch the x-axis. So when we solve algebraically here, we get minus k is greater than a quarter. Then we multiply by k, so therefore k is going to be less, the sign will change, less than a quarter. So you can solve this in many ways, but I was just expanding your knowledge. Otherwise, the algebraic technique, since we're doing algebra, is the main one, but the others are not excluded. 4 marks. So obviously stating that the discriminant has to be less than 0 is important. Putting this in standard format is important. Substituting into that nice format, and the solution, that's how we get the 4 marks. And that's how we walk away with those fat 26 marks. All right. Good. So that's what we do here. Okay, so these are some of the techniques that will help you survive functions. And obviously, you would want to find out, why must k be less than minus 4? Right? Does it make sense? Well, this is a vertical shift. Of which graph? This is a vertical shift of this graph, if you think about it. Is it not? Because k is a constant. So essentially, we can decide and put this value, say for example a minus 1. Minus 1 is less than a minus quarter. So when you put a minus 1 there, can you see there's already a negative? So minus and minus will make it a positive to show that this is a shift upward by that unit. So it's an upward shift, even though it comes out very ridiculous. It's all about what is happening in that environment. So always interrogate these values for sense so that you can understand what is going on. Even on this situation where we've completed the square, if k, for example, is minus 1, so this is going to be 1 minus a quarter. That is a positive answer. And we can see that would be a positive shift. So anyway, guys, I was just giving you extras so that your understanding is enhanced. So there's a lot of space here. We can answer a question. Okay. So question 2 is always on sequences and series. So we're given a geometric sequence. There it is. So this is a geometric progression where we've got 10, 5, 2, 5, and 1,25, and then it goes on. Okay, so now we are told, what are we dealing with? It's a geometric progression. So what do we know? This is our a value, and we need to find our r value. So 5 divided by 10 is a half. So that is something you need to do even before you start answering questions, because there's no time. Now I told you, calculate the value of the fifth term of the sequence. So in a geometric progression, Tn is basically a times r to the exponent n minus 1. So this implies that T5 is going to be a is 10, r is a half, to the exponent n is 5 minus 1. Okay, so here just put it on the calculator and not waste your time. Okay, so that is to the exponent 4. So this gives us a 5 over 8. Okay, great. So that is simple. Okay, so here you can round off to 2 decimal places, but 5 over 8 gives us 3 decimal places, is it not? Yeah, so this messes up everything. So sometimes just leave it as it is, because this way you are avoiding trouble. So substitutions and answer is what is important. And in fact, what in these substitutions is the common ratio more than anything. Okay, so 2.2 says determine the nth term of this in terms of n. Of course, Tn is equal to a times r to the n minus 1. This is 10 into a half to the n minus 1. And that is it. Because if we're to express this in terms of n, we cannot proceed further than this. So again, we are getting 2 marks here. Well, we can just say 2 marks for the answer. You could do it by inspection, essentially. So 2.3 says explain why this infinite series converges. Okay, for a series to converge, we know that r has to be less than 1, greater than minus 1. And what is r in this sequence is a half. We can see that a half is less than 1, greater than minus 1. And that's exactly the explanation why that series converges. We can say, a series converges. A geometric, it's always a geometric series. A geometric series converges when r is less than 1, greater than minus 1. We can say since r is a half for the above series, it is therefore clear that the convergence is that. We can say therefore the series converges as a half is less than 1, is less than 1 but greater than minus 1. So sometimes you can find a way of putting the words together nicely. I'm very, very, very bad with words, so I'm very clumsy, you know. I just put things wherever I can, so please be as organized as you can. So we know that a geometric series under normal circumstances converges when r is less than 1 and minus 1. Since r is a half for this above series that we're talking about, therefore that series converges as this half is in that domain. Okay, so 2 marks here. I don't know. Saying that it converges and stating the constraint of R is what is important. And then of course we're just giving a background information at the top. Because they said explain. So when they say explain, attempt to do so. Determine the sum to infinity and sum of the n terms in the form. This is the standard exponential form where Sn is the sum of the first n terms of the sequence. Easy. Sum to infinity minus Sn means we have A over 1 minus R minus A into 1 minus R to the n all over 1 minus R. Okay, so that is just the formula we're going to employ. So this is 10 over 1 minus a half minus 10 into, maybe let's make this one big, 1 minus a half, like that. All of this is divided by 1 minus a half. Okay, so let's work it out. So 1 minus a half is a half. 10 divided by half is 20. Minus, this is going to be 20 into 1 minus this half to the exponent n. And then when we sort this out, we FOIL this out, it's going to be 20 minus 20, and then that one is going to be plus 20 into a half to the exponent n. And we can see these two cancel out. So our answer is 20 into a half to the exponent n. And we can see that is the format. We've got a coefficient 20, we've got the base a half, we've got an exponent n. So it is sorted. So nice and easy. So this is important and that is important on its own. And essentially, Lord, what can we do here? 2 marks for the answer. I don't see where the other mark is. Either way, we move on. So ibingama cry nice nje manje khawuhlafune and enjoy some good marks there. Okay, I've got a lot of space here, but for you, you have to be in the new question. Now, we're told to consider this series. Sn is basically minus 3 plus 5 plus 13 plus 21, and it goes on to the nth term. Okay, great. So this is a series. So let's explore this series. This is the first term of the series. Obviously, this is A. But we can see when you say 5 minus minus 3, it's 8. So we can see here that the D is going to be 8. Because also 13 minus 5 is 8. 21 minus 13 is also 8. So this is suggesting that, okay, we've got an arithmetic sequence here. An arithmetic series, sorry. Okay. With A as minus 3 and D as 8. Again, this exploration is something you need to do without even being asked a question, so that it's easier to answer questions. Determine the general term of the series in the standard linear format. Of course, they're a little bit dictating. We know that B is the coefficient, which is the common difference, essentially. And then K is the variable. As you can see here, it's still the variable. So that is what we're going to be doing here. We know that TK is essentially going to be equal to A plus K minus 1 times D. Instead of D, we put a B there. But it doesn't really matter. We can put a D. A D is not going to hurt, because even if we look at it as a B, it's not a big deal. Okay, so we go on and substitute minus 3 plus K minus 1. D is 8. This means we've got minus 8 plus, minus 3 plus 8k minus 8. We can make 8k lead so that it's in the format that is required. Minus 8 minus 3 is minus 11. Okay, so here what is important is just following the instructions essentially. Otherwise you could have used n, but if you're using n it means you're not adhering to the request. So please learn to give to the requests, because these are dictations that you cannot run around, because if you do so you're going to lose marks for a very simple question essentially. So let's go on forward to and sort it out. How many marks there? 2. Easy. Substitution and the answer. And then of course let's check if this represents our series. When we put a 1 for k, this is going to be 8 minus 11. That's a minus 3. If we put a 2 there, that's 16 minus 11. That's 5. Can you see? So it represents our sequence. So here you can check and be sure that you are doing the right thing. There's no need to lose marks in these kinds of questions. Show that the sum to n terms is that way. Okay, that's easy. We know that Sn is basically n over 2 in an arithmetic series into 2a plus n minus 1 times d. Okay, so this is n over 2 into 2a was minus 3 plus now n we don't know, d is 8. Okay, so we just sort it out. N over 2 essentially into, this is going to be minus 6 plus 8n minus 8. Okay, so this is n over 2 into 8n minus, this one is going to be minus 14. Okay, so when we do FOIL method, this is n over 2 times 8n. This becomes 4n squared minus this n over 2 times 14 becomes minus 7n. Okay, nice and easy. And that's how that's how it was proposed. So again here we are scoring. Oh, I skipped a question, my lord. Yes, I answered 3.3. Goodness me, I rushed for 3.3. There's a question here that we're writing this in sigma notation. Ish. Okay, it's no trouble. We can move this one down. So we have to answer 3.2 here. We are writing this in sigma notation, so we can see that minus 3 plus 5 plus 13 plus 21 plus dash dash to n terms is equal to the sigma of what? Now we can write this one in terms of n because they said Sn. So it's going to be 8n minus 11. That's our general term, right? Then we're going to start with n. Maybe let's just write k. We write k as it is. Then we can say starting from k is equal to 1 to k is equal to n. Okay, so that is it. So we're getting 2 marks for our sigma notation. And now here we're getting 3 marks. Wow, that is strange. So we're getting a mark here. The answer was already proposed though. I don't know why these guys are like this. So maybe substituting the common ratio and like that, maybe 2 marks. And then we can say 1 mark for ensuring that this answer is so, because I cannot find, I really cannot find where these marks are coming from. So let's do 3.4. So 3.4 says another sequence is defined as, we've got Q1, Q2, Q3, Q4, Q5. Now let's explore this. We've got a 6 here. Every other term has a minus 6. Okay. But then what do we see? We have a minus 3 there added. And then here we've got a minus 3 plus 5 added. And then we've got a minus 3 plus 13. Okay. What are you noticing here, guys? We are essentially adding the terms of that arithmetic series above in here. Can you see? The first term was a 3, so can you see Q2 is this minus 6 plus that first term. Then Q3 is minus 6 plus the first two terms of that sequence, and it keeps going. So all we are dealing with is a minus 6 plus that sum or that series, of course adding it one after the other. So this question says now, for 3.4.1, write down the numerical expression. The word expression, it means it has to be like that. And as we can see here, what is next? Because we are adding the sum of these terms as they keep going. So the next term here would be obtained when we add 8 to 21. And that is going to be 29. So that's what we're going to have here. So 3.4.1. We know that Q6 is going to be equal to minus 6 minus 3 plus 5 plus 13 plus 21. Now we're adding the next term there. That's going to be 29. Okay, great. So this is the expression, so 2 marks for that. Great, so we've got 3.4.2. This question says now calculate the value. Now once they say the value of Q129, this is going to work. But now let's observe a few things here. Q129 is basically going to be Q129 is given by minus 6 plus. Now we're going to have Sn, which is S128. Why do I know it's going to be S128? It's because if I look at this term Q5, how many terms of that Sn did I end up with? 1, 2, 3, 4. So Q5 had 4 terms added in that sequence. So Q129 is going to have 128 terms of that sequence added together, right? Right. So this is going to be minus 6 plus. What is the general term for Sn? There it is. We've got it. So this is going to be 4 into n is 128 all squared minus 7 into 128. So can you see this is an integrated question? So you have to always observe. Sometimes certain questions build from one another. Okay, so we can safely say Q129 is going to be minus 6 plus essentially S128. This is minus 6 plus, this is 4 into 128 squared minus 7 into 128. So we wanted the numerical value, so we're going to calculate it. Minus 6 plus 4 into 128 squared minus 7 into 128. So I'm getting a 64,634 as my answer. So that is it. Okay. So, very nice question. I am telling you, this is a higher grade question. Sometimes it can fool a lot of people and cause them to crack their skulls because they think this is difficult, but it's a matter of being observant essentially. Anyway, so let's see, we were getting 3 marks. So for me, this substitution into actually this 128 and the general substitution is important here, and the answer. So this is how those 3 marks are scored. And we are walking away with 12 marks. I'm a cry nice, to be honest. You know, I'm a cry nice. So how else could you have solved this? Most likely this is a quadratic sequence. As you can see, they said Q1, Q2, Q3. So this is suggesting this is a quadratic. So this is minus 6 going into minus 9 going into, this is now minus 6 minus 3. This is minus 9 plus 5. We're getting minus 4, right? And then we go on to the next one. So this is basically minus 4 plus 13. Minus 4 plus 13, that's 9. Okay, and then we leave it. Let's see, what are the first differences? 9 minus minus 6. It's basically 9 plus 6, which is minus 3. Okay, and then this continues. Between these two, 4 minus minus 9 is going to be 9 minus 4, which is 5. And then here, 9 minus minus 4, that's going to be 13. And we can see here, this is 8, this is 8. So we can see that the second differences are constant. Can you see? So this is basically a quadratic sequence. So you can work with it as you know how. This is 2a, this is 3a plus b, equaling that term right there. Maybe let's choose another color. Equaling that term, and then here we're going to have a plus b plus c equaling this other term. What is that story there? So equaling that term. So we can find the general term and then solve for term 129. So for 3 marks, you can work a bit harder or you work smarter. It's up to you. So this is how questions like these are handled. So I'm a cry nice, eh? I'm a cry nice. Okay, let's move on to question 4. Okay, so question 4, we are given a function f is basically 2 to the exponent x plus 1 minus 8. Now let's analyze what we've got here. Now, if we look at this situation right here, that is the base, okay? And that is the exponent, right. And then we have a bit of a situation. Normally, we need to have a coefficient of the base. And we can see that there's nothing there. When there's nothing, there's an invisible 1 there. So what does that invisible 1 means? It means our a is greater than 0. Right. Why do I know there's an a there? Because the standard format is that f of x is equal to a times b to the exponent x minus p plus q. This is the general format for, so this is the general form or the standard format of our exponential equations that you learn in grade 11. So let's see, now look at our base. Our base is greater than 0. So again, it's actually not 0 but 1. Our base is greater than 1. So what is that supposed to say? If our base is greater than 1, together with an a value that is greater than 0, it means our exponential function is a function that appears above the horizontal asymptote. And what is that horizontal asymptote? It's minus 8, or you can say it's a vertical shift. So the horizontal asymptote is this one here at minus 8. That is x, that is y, that is the origin. Now we're saying this combination, say this is an increasing function that appears above the horizontal asymptote. So this is what we've got, folks. This is what we've got. So we know that our graph is going to look something like this. Are we correct about the x-intercepts, therefore? Is the x-intercept positive for this function? Is the y-intercept positive? You can actually work it out and be sure that you're drawing this sketch into the regions that this dictates. Again, if you take 8 to the other side, when y is 0, this is going to be 8 is equal to 2 to the exponent x. 8 is basically 2 cubed. Now we've got the same basis, we equate the exponents. X plus 1 is equal to 3. 3 minus 1 is 2, so x is a 2. So this is a correct region for our x-intercept. Y-intercept x is 0, so this is 2 to the exponent 1, which is 2. 2 minus 8 is minus 6. So that region is correct. So this sketch is perfect for our exponential function. So please, guys, be able to analyze these things, learn the characteristics of each function so that you can cruise. So we've got 4.1. What are we told here? Write down the equation of the asymptote of f. Obviously, it's going to be the constant term. So y is minus 8. Okay, as you can see on the graph there. Nice and easy. Easy 1 mark there. I'm going to cry nice. Now the next thing says sketch the graph of f. Clearly indicate all intercepts with the x's as well as the asymptote. So now they are really pushing our luck. So we already know what our sketch looks like. And in fact, we already worked out these things in our heads, but we have to show it now. We can't just show up with a sketch that is perfect. We have to show how we got things. We need an x-intercept. For an x-intercept, it is such that 0 is equal to 2 to exponent x minus 8. Sorry, x plus 1. Then this implies that 8 is equal to 2 to the exponent x minus plus 1. Here when. So this is 2 cubed is equal to 2 to the x plus 1. Same basis, we simply equate exponents, but now we're interested in x, so I just rearrange. Okay, this implies that x is a 2. Therefore, my x-intercept is such that 2 is to 0. So this is very important. This is very important. So I'm moving fast forward. So the next piece of argument is that for the y-intercept, it is such that f of 0 is equal to 2 to the exponent 0 plus 1 minus 8, which is minus 6. Therefore, the y-intercept is such that 0 is to minus 6. Now with that sorted, with those two intercepts sorted, so the graph of f is this one. The graph of f of x is equal to 2x plus 1 minus 8. Is, of course, you will have agreed, I don't have it now, so I'm just going to make my own. Okay, but for today's my sketch. Remember, the sketch doesn't have to be accurate, but just indicate what is what. Even if this looks to be sitting there, as long as you write it's a 2, it's important. But you can then do it with a ruler and make it a bit more accurate. It's fine. A freehand drawing is going to be a bit better than this. The electronics sometimes have a way of defeating a person. Otherwise, this is sorted, guys. That's 4 marks. First of all, for the shape, we're getting a mark. For working those two intercepts, because we didn't have them, those ones each get a mark. And for showing the asymptote. So that's how we score those 4 marks. Nice and easy. 4.3 says the graph of G is obtained by reflecting the graph of f in the y-axis. This is what we call a horizontal reflection. And what is a reflection, guys? It's a flip. It's just a somersault. Now this horizontal somersault means we make -1 and multiply the x values. That's all we do, because with a somersault in a horizontal plane, only x values change. The y values remain the same. So this means that g of x is going to be equal to 2 to the exponent minus x plus 1 minus 8. So can you see, we just simply multiply the x with the negative. Be careful not to multiply that entire exponent, only the x values. Okay, so that's easy, 1 mark. So if you didn't like to write this as an exponent with a negative x there, you can work it out. Say g of x is going to be 2. You factor out a -1 into x minus 1 minus 8, right? Now you show that this base is to the exponent -1, all that raised to that exponent x minus 1 minus 8. And then this is basically a half, all raised to exponent -1 minus 8. So this is how you can solve it. Sometimes when they are hitting you with a bit of a headache, they can ask you, what is the transformation of this? Or explain this transformation of, essentially, say, explain this transformation of f to g. They put it this way, you know. So if you're not comfortable working things out, you wouldn't know what happened here. So all we did here, we just essentially reflected it on the x-axis, because now you have to work it back to show that this is a minus x. Of course, we just change this to a negative power, and then a power with a negative exponent, and then you simply multiply those, it goes back there, and you will then learn from the minus x that all we did, we essentially just did a horizontal reflection. So this is an option of writing g of x. You can write it this way, or you just leave it in a simple way so that you don't lose unnecessary marks. So this 6 marks being a cry nice, ne? Let's move on to question 5. Okay, so let's start question 5 here. Okay, so question 5, we are given h of x is equal to 2x minus 3, and we can see that 2 is positive, right? And so we can see this graph has a positive gradient, so that's good. And the y-intercept, remember that constant term is the y-intercept, and we can see it there. There it is. So this is definitely the graph we are talking about. Positive gradient with the same y-intercept. So that is the signature of our graph. And then we are told the x-intercept of h is q. If q is the x-intercept, it means it's some x value and 0, because the x-intercept implies y is 0. Then we've got a function, so we can work that out, not a problem. So we are also given a domain. Now this is something to think about deeply. Why are they giving us a domain? Well, we'll find out. So they're telling us that these graphs have these limits, -4 and -2. Sorry, 4 and -2. So this is the horizontal extent of our graph. And essentially we can do our vertical extent, which would be the range of our graphs, right? So the range, we just substitute 4 into the equation. So this is 4 by 2, that's 8, minus 3, that's 5. And then we substitute a -2. This is -2 times -2 is -4. -4 minus 3 is -7. So we've got our range and we've got our domain. So this is the analysis you can do there quickly. So let's start answering these questions. So we've got h of x is equal to 2x minus 3 for the domain x equals and less than 4, greater than and equal to minus 2. Okay, that's all right. 5.1 says determine the coordinates of q. So that's easy. So we know that q is an x-intercept of h such that 0 is equal to 2x minus 3. Therefore, x is going to be 3 over 2. Therefore, our q is going to be 3 over 2 and 0. That's it. So this is very easy. So sometimes, treating maths like you are writing some essay, ndafundisa uba awuvele uphendule njengathi wehle emthini or uwentabeni. Uyondlalela kancane kancane. Naxa uzongena ezingubeni awungeni njengenyoka, unyebelezele. Uyaqala wendlule, ujonge uba akho zicawu, nawe uzulala phezu kwezinambuzane. Uvuke sowudumbile ungazazi uba udonjiswe yintoni. Kanti awukho careful, yewena. So substituting that situation is important in solving the x value. We can say the x value at q even. And then we present this as coordinates because that's the question. You answer the question. So 5.2 says write down the domain of the inverse of f. Okay. Now we know that the inverse of h. Now we'll take as a domain the range of f because these two interchange. So what is the range of this function of h? In the inverse it becomes the domain. So can you see? Now we understand why they gave us that domain, because it's going to help us to work out the range of h, of which will become the domain of the inverse. And the question said write down. So this is easy. This is easy. So how are we going to do this? We're going to just write the domain of the inverse of h is equal to a set of x values such that. Now we're going to say x here must be less than or equal to. But now our trick is to use the range of this. So the range is going to be basically 2 into 4 minus 3. So we're just showing the determination essentially. Greater than or equal to 2 into minus 2 minus 3. So we can say here this is basically equal to a set of x values such that when you sort this out, this is minus 7. And that is going to be 5. Can you see? We have done our business nice and easy. Of course, the question said write down. So we knew that the inverse interchanges the domain with the range of the original function and vice versa. So basically, we are getting a mark for those values because determining those values, we needed to use that, right? Right, and then the whole setup. So that is 3 marks. So this is very important. Of course, there's plenty of ways you can write this, but I prefer the set builder notation. It looks mathematical and more informative for me. The shorthand techniques don't impress me that much, but you can use them. Easy. So here I was just showing you how you work this out. So this is basically the thought process. It does not have to appear, but even if you showed it, the answer is important. But be careful when the question says write down, because should you end up writing extras, you end up being marked for the first thing. But even that is effectively this. So be careful of what you write when they ask you to write down. When we are being asked to write down, this is the solution that we are looking for. Okay, 5.3 says, sketch the graph of the inverse of h in the answer book. So I don't have it, and clearly indicating the y-intercept and the endpoints. So I don't have the grid. So first of all, I know my h of x is equal to 2x minus 3. This implies that the inverse of h in terms of x is going to be, maybe let's work it out. It's going to be x, it's going to be, remember the inverse of h in terms of x is such that we swap the values. It's going to be x is equal to 2y minus 3. Then we solve for y. We know that 2y is going to be x plus 3. Therefore, we isolate y is going to be a half of x plus 3 over 2. Can you see that? So here I can just use inspection now and say this is going to be a half of x plus 3 over 2. Remember, that was my thought process. Nothing serious. Okay. Alright, so I'm just trying to save time and space. Yes, sometimes you're not given that much space. So what do we do now? We need to sort up this graph. So all we need is an x-intercept. Why? Because the y-intercept is already the constant. So we don't need to determine that. So it suggests that 0 is a half of x plus 3 over 2. This implies that minus 3 over 2 is equal to a half of x. Then we divide by half. Therefore, we can tell that x is going to be minus 3. Therefore, our x-intercept is going to be minus 3 and 0. So, this is fairly easy. So we can just draw the graph here. Is it vertical? It looks vertical. That's the origin, that's the y. Now we know that we just want a graph that is positively skewed, basically. Okay, but remember this is a sketch before to, so sometimes try not to be too accurate. Sometimes it irritates me, you know, it really does. Yeah, doch. Okay, so there's our graph. But now, remember there's some catch to this graph. There's a catch here. So it says here we have to indicate also the endpoints. So what would be the endpoints? That is the domain. So the domain, we have to know that that was at minus 7, right? And that other endpoint, we can just cut it here and see that that was 5. We got 5 here. Great, so let's take it down to that endpoint. And be careful, this one you can't put arrows to suggest that this is continuing. It ends, so you stop there. And if you end up with an arrow there to suggest that we are continuing, you are applying for your death, okay? Remember that. So this is minus 3, so that is 3 over 2, or simply just 1,5. So we have indicated everything. So we can label that this is the graph of the inverse of x. So please be very, very, very careful on what you are doing, because simple questions can take you down. So how many marks were we scoring there? 3 marks. Obviously the shape, showing the gradient, and these endpoints. Because these endpoints are an important value. So we're getting our extra mark there. So that's how we score those 3 marks, and let's move on. So 5.4 says, for which value or values of x will h of x equal the inverse? Obviously, this one is an algebraic calculation, unless on the grid you have this graph drawn, because the inverse graph, because this is already minus 2, so it's going to be cutting at minus 3, somewhere like that. You know, maybe let's try and elevate it a bit more. Foot. So if the inverse looks something like that, assuming that here we've got a minus 3 there, and then we've got a 1,5 or 3 over 2. So we are looking for this point of intersection. What is it on the x-axis? Okay, so we are looking for that value. Not a problem. Obviously, we can solve this algebraically. So we can just simply take the equation of the other graph. So we know that, well, h of x equals the inverse in terms of x, implies that 2x minus 3 is equal to a half of x plus 3 over 2. And then we move things around. We take this half to that side. 2 minus a half is 1,5. So this is 3 over 2x equals, and then we take 3 to this side, and then 3 plus 3 over 2. We take this and multiply the 3. It's 6 plus 3. It's going to be 9 over 2. Therefore, our x is now essentially 3. Okay, that makes sense because this is before 4. Although this is not drawn to scale, but it makes sense. Okay, so we can say that is it, because we're supposed to solve. It says for which value or values of x. So this s is just there to confuse you sometimes. So that is the one. So 3 marks. So essentially equating these two, and the answer is important. Unless on the graph one could easily read that, you would have to indicate it and solve. Okay, great, because you will have drawn that to scale at least, but I don't have that luxury now. Okay, not a problem. So let's move, guys. We don't want to waste time. So we've got 5.5. It says P. Okay, now where's point P? There's our point P. With x is to y is the point on the graph that is closest to the origin. So what does that word closest means? This is the minimum distance. Okay, minimum distance basically. So you see the English can play tricks on you if you're not paying attention. So already this is suggesting this is a higher order question. It's not one that you can just look at and get an answer. You have to perform at your very best. And you can see the mark allocation is also saying it, that there's no child's play there. So if this is closest to the origin, it means what are the coordinates of P essentially? If this is x, and we are told P is a point on the graph of h, right? The graph of h is that one. So that means y there is basically 2x minus 3. So that is the trick. That is the trick. So you just show that point, and we know that at the origin we've got 0 and 0. So that is easy. So we can just simply say point P is effectively x is 2x minus 3. That has to come out because it's important. We can say then, okay, let's not even say then. We can say OP. Now remember, OP, we're going to use the distance formula, but the distance formula is going to introduce a square root sign. So we can just say OP squared is equal to x at P minus x at O all squared plus y at P minus y at O all squared. Then we go on and substitute. X at P is x minus at O is 0. all squared. This is basically 2x minus 3 minus 0 all squared. So this is basically x squared plus, we FOIL this out, it's going to be 4x squared. 2x times 3 it's minus 6x, minus 6x times 2 it's minus 12x, minus 3 squared is 9 plus 9. And then we sort out our like terms here. We've got essentially x and x is going to give us 5x squared minus 12x plus 9. Now remember, this is the distance OP squared. So we know that for a minimum OP squared, it is such that OP squared prime, the derivative, must be equal to 0, right? Right. Now we do the derivative of that expression is going to be 10x minus 12 is 0. Then we solve for x here. We know that 10x is equal to 12. Therefore, x is going to be 12 over 10. That is 6 over 5. Right. Right. We can say, now we substitute x into the OP. We can say here then OP squared is going to be 5 into 6 over 5 all squared minus 12 into 6 over 5 plus 9. Let's sort it out. So we've got 5 into 6 over 5, that is squared, minus 12 into 6 over 5 plus 9. I'm getting a 9 over 5, okay? We can say therefore OP is going to be the square root. Is going to be the square root of 9 over 5. Let's see, square root of the answer there is giving us a 1,34 units. Okay, so that question is a bit silly, so it applies calculus. So can you see? You already know these things. Now this is a grade 12 question, so no grade 11 can do this, but I think there is a way of doing this in grade 11. But you would have to understand a lot for you to solve this. Let's see, how would a grade 11 answer this question? Once we hear this word minimum, remember for minimum and maximum, we are usually referring to some quadratics, isn't it? Completing a square. So obviously that word suggests that the angle between this line and the origin should be 90 degrees. So this is the vertical distance. When we talk of a minimum, we're talking about the vertical distance. Let me try to make it slanted as this is. So this means we've got 90 degrees there. Right, because the minimum or maximum distance from one point to the next, it has to be a vertical distance to a line that passes through that point. Now this means we've got a triangle. See that yellow triangle? What can we do with this triangle now? Now what we can do is that, okay, we can see that, look, we can look for the angle of inclination of this line, H, because we've got the gradient, because that angle of inclination is equal to that inside angle. Is equal to that inside angle. These are vertically opposite angles. And by the way, we found out that the x-coordinated q is 1,5. So this means this distance here is 1,5 or 3 over 2. So can you see we've got an angle now? We've got the hypotenuse side. We're looking for the opposite side, which is OP. So a grade 11 would have to apply analytical geometry as well as trigonometry. Of course, with the understanding that that would have to be a perpendicular distance. Right. So let's say now in triangle OQP. What do we know? We want this angle OQP. It is going to be the shift 10 of that gradient of this line. Why? Because these are vertically opposite angles. Because the angle of inclination of H is vertically opposite that angle, and therefore they should be equal. So let's sort it out. What is that? So shift 10 of 2 gives us a 63,435 degrees. Remember, this says we're rounding off to 2 decimal places, so I'm going to make it a bit more so that I don't lose my accuracy there. Now we can see that in that triangle, we essentially are looking for the opposite. We've got the angle, we've got the hypotenuse. So we can essentially say now sine of this angle OQP is going to be the opposite OP over hypotenuse, which is OQ. Alright, this implies that we've got sine of 63,435 degrees is equal to OP over OQ. This is 1,5. Therefore, OP is going to be 1,5 times the sine of 63,435 degrees. What is that equal to? So 1,5 into sine of 63,435 gives us the same answer, so 1,34 units. So this is how a grade 11 would think of it, provided they understood that the closest would mean this has to be a perpendicular line to that line of the graph from that point. Okay, but if you didn't get that, you are dead. Okay, so this is essentially how a grade 11 would do it. That's an option, but a grade 12 knows we can apply calculus, and that's just as easy as that. All right, okay, all right. So obviously that's a skilled way of sorting that up. Getting this expression for OP squared is important, and essentially doing the derivative and equating it to 0 is essentially, okay, let's just say doing the derivative is fine, and solving for x is important, and the final answer. The rest is history. Okay, great. So let's move on. Before we're to, we've got work to do. So we've got here 5.6. So 5.6 says, given that h of x is equal to f prime x. So this means, if this is the case, remember, what is this f prime of x now? It is h of x, and that is linear. So what does that tell us about the original function f? It means f is a parabola. Because when we take the derivative of a parabola or quadratic, you can use that word, quadratic. So if we take the derivative of a quadratic expression, we get a linear expression. So this is suggesting that f, the original, is quadratic. Okay. Now, where f is a function, can you see, defined in the same domain. Okay, so why are they giving us this domain? Well, we'll find out. It says, now explain why f has a local minimum. Now, my only fight with this one, for a parabola, that word does not exist. You can't say local minimum. Why? Let's look at our parabola. We've got a positive gradient, so it means our a value is greater than 0 for our f. So suggesting that our f is like this. So let's see. We don't really care where it's turning, but we're just going to do it anyway. So let's say f looks like this. Can you see? Where is the minimum value? The minimum value is the y value at the turning point. So there is the minimum value. Can you see? Now, do you see this graph below this minimum value? The answer is there's no graph below that minimum value. So you can't call it a local minimum. This is basically a true minimum. It's not some sort of like what looks like, but it's not. It's not a false minimum. Okay, but if you were to compare this to a cubic function, let's just say we've got a cubic function that looks stuff like this. We don't really care for accuracy at this point. We're just teaching now. We are teaching you some pearls so that you understand what these things mean. Now let's look at this one. Now, where's the minimum? This is a minimum, right? And this is what is meant to be a maximum. But can you see these graphs continue beyond those values? So the graph is still seen beyond the minimum. Can you see? I mean, beyond the maximum. And we also still see the graph below the minimum. Hence, we call this local. This is a local minimum. Because it's not a true minimum. Why? Because the graph is not limited there. As well as that would be a local maximum. Again, because the graph is not limited there. So for a cubic function, we talk of local maxima and minima. But for a parabola, it's a true minimum. So this is not good to say local minimum. Okay. So be careful of things like that. But again, you can't correct the examiner when you are doing the exam. You just go for it, right? So the question says, why does this one have a local minimum? We can see that the a value is greater than 0. How do we get this? It's from the gradient of the first derivative. If the gradient of the first derivative function has a positive gradient, it means a is positive in the original function, and therefore it's a smiling parabola. So we can say, well, why does it have a local minimum, actually a true minimum? It is because since the graph, or should we say, since the first derivative, h, let's just say, since the derivative f prime of x has a positive gradient, we are learning this from this. Okay, since this one has a positive gradient, we can say it follows that f as a function has an a value greater than 0, right? And if a is greater than 0, suggesting that the graph of f is concave up. Because when a is greater than 0, it is concave up. Therefore, f has a minimum value at its turning point. Or you can say at its lowest point, because the minimum value is the lowest point. So yeah, that is a bit of a situation there. It's very difficult to put words together again. But again, you can see here, they're just testing your understanding of the subject in the very best way possible. So obviously, there's a few things, but what takes the crown here is noticing that the a value is greater than 0, meaning the graph will be concave up. And as a result, it will have a minimum value. So here you can get your 2 marks. However that explanation comes about. So this is the best way I can put it, but you guys know the English better than me. And you guys are smarter than me also in knowing how to put things together in a palatable way that sounds very attractive. Okay, I'm old school, so yeah, there you just had to get to the point. We know the telegraphic ways of talking rather than these fancy ways that, take turns and twists. Most, you guys are the smartest. So essentially, this question is also one of those questions you're not going to just look down on and think you have it figured out. It can challenge you. So it's a higher grade question also. Now it says write down. Can you see? Write down the value of the maximum gradient of the tangent to the graph of f. Now we have a situation here. What was the domain of this function? So if we use this one, what was the domain in which this one was written? Can you see it was 4 and 2? So this is basically minus 2 and 4. Remember, these are not the intercepts, but this is the extent of the graph. And as you can see, the graph on this side, if we just draw tangent lines, the graph on this side has negative tangents, right? Meaning it has a negative gradient. Here, the tangents are essentially, I don't know why I took it out, are essentially 0, because at the turning point we get a 0. So these ones are positive again, but can you see as we move from left to right, the gradients are increasing. As we go up, this is the steepest gradient there, because now the limit, which is our upper limit of the domain, will give us the maximum gradient. Can you see there? So now I understand why they gave us this domain. So this lies with that domain, because we can see a parabola as we move to the right on a positively, okay, let's not say positively skewed, but on a concave up. As we keep moving closer to infinity, the gradients are becoming steeper and steeper, the steepest being at infinity. But now our infinity was cut short to 4. So that means 4 will have the steepest gradient compared to any other. And that is what will give us the maximum gradient. Great. So we know that the gradient of f is given by the first derivative of x. And that first derivative of x, this therefore says the maximum gradient of f is going to be f prime of 4, because at that 4, which is the greatest extent, or should we say the greatest gradient in this limited graph, is going to be that one. So f prime of 4 is basically 2 into 4 minus 3. Remember, f prime of x was essentially this function right here. So we just simply substitute there. So why are we saying that is going to be f at 4? Because that would be the steepest gradient. So yeah, must be referred to. This is 8 minus 3, which is 5. Again, the question said write down. So all of this is your thought process. The answer is this one. So the 2 marks is with the answer. Actually, they're giving 1 mark. Can you see? It's not so easy though. It's not so easy. But in any case, you needed to understand that this domain says the graph doesn't go beyond this. So in actual fact, the graph here, we can't have arrows on the graph. Because on this graph now, we don't have those arrows. This is where the graph ends. So those arrows do not continue. It doesn't go to infinity, but it stops there. So those are the end points for this graph. So again, question 6 was also a higher grade question. It's not an easy question. And it's easy to not get it right while seeing everything in front of you. So this is how we can take these 19 marks. Again, those last 2 questions. The higher grade type of questions is what you get in your NBTs. So always remember, in the NBTs, what looks very difficult is basically higher grade type questions. So practice these as many as you can find in the past exam question papers. You should be ready to ace your NBTs. There's nothing you need more than just knowing the. You have to keep an open mind. Okay, guys, then we are sorted. We are sorted. Not a problem. So let's move on before to the next question. I'm losing time, and I don't like to lose time. So let's start here. It looks like we have a lot of space, but we can start on a new page. Question 6. Okay, question 6, we still have functions. The graphs of f. So we've got f, which is a parabola. This is the parabola you get in grade 10. Right. So let's see. What is this parabola? We've got the coefficient of x squared is negative. So a is less than 0. This is very good to note. So what does this suggest? It suggests that our parabola is basically concave down. Ne? It's concave down. But now we don't have a b term. That means the axis of symmetry is 0. And that means the constant term, since the constant term always gives us the y-intercept. But now that y-intercept is essentially now the turning point. So our graph looks something like this. Okay, so this means this one is going to be at 18. That becomes the maximum value, because you know that this is going to be less than 0, because x squared is either 0 or positive, but multiplied by negative will make this to be a negative answer. So that means now if we're taking the greatest value, the greatest is when x is 0 here, so that this thing becomes 0. The greatest is 0 for this expression. Now, if that is 0, we throw it away. That becomes the maximum. So please be able to interpret things like this so that you can quickly work out what you need to work out. Okay. So here we don't have a domain. So that's an element of real numbers. So we can put our arrows. Okay, so this is what our parabola looks like. And where is it? There is f. And f is exactly the shape we are looking for. So this implies that this t point is going to be 0 and 18. So can you see it becomes the turning point and the y-intercept. And then of course we can work out the x-intercepts here using the equation. It's not a big deal. And then we've got g of x, which is given in a hypothetical manner. So that means we just need to look at g. Maybe let's use this color for g. So there is g. So when we look at g is concave up. So if it is concave up, it means our a value is greater than 0, right? That's all we can see. But of note is that g passes through the same point t as the y-intercept. So this means our c value is also 18. But now let's look at this turning point. How can we establish what that b value should be? Now if we look at the turning point is on the positive x-axis. The x-coordinate is on the positive x-axis. This is suggesting that for this to be positive, b must be a negative. So b must be less than 0 as well. Right. Why? Because the x-coordinate at the turning point is minus b over 2a. We can see a is positive. If b is essentially negative, then we're going to have negative times negative giving us a positive, and that becomes a positive. Can you see? So that is the story. So guys, be very, 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 very analytic, because I can tell you these questions will cease to become a problem. But if you don't analyze and you just want to go through the motions, because I know how you guys are taught. You are taught just to survive. And this is why it's so easy not to get good marks. But now I'm teaching you to not just survive, but to excel. That's why I created this channel. Sorry. So the reason I created this channel is to give you what you wouldn't get elsewhere that easily. But again, it's just, bits and pieces, because most of the stuff is standard. So it's pretty much what you would get anyway. But if you pay attention and you follow every analysis I give for any question paper that I answer, there and there are some bits and pieces that you can put together as part of notes that you can later use to your advantage in getting the best mark. Okay, let's go on, guys, before we lose time. We're told points P and Q are the x-intercepts of F. So here we know that we've got some value x and 0. And also we've got some value x and 0. Because that's what x-intercept means. And then we know that points Q and R are the x-intercepts of G. So this is again some x value and 0, and the other one is that it's a common x-intercept. Okay, now S is the turning point of G. Okay, so here we've got some value x and some value y. Not a problem. T is the y-intercept of both F and G, and we can also see that it is the turning point of F as well. Great. So we are sorted. Now what do? We put it to the test. So we've got 6.1. We were given f of x is minus 2x squared plus 18, and g of x, which is equal to ax squared plus bx plus c. So this is the story that we've got. And essentially, they're just as complicated as you see them. Now, what is the story? It says write down the coordinates of t. Can you see? Analyzing and going a bit further, we already answered that question. So t is going to be 0 and 18. Okay, that's easy. It's the constant term. Constant term is the y-intercept. So you move on. 6.1.2. says determine the coordinates of Q. Can you see Q is the x-intercept of F, which we have a full equation. So we know that Q is the x-intercept of function F, such that we know that we substitute 0 there is minus 2x squared plus 18. This implies that minus 18 is equal to minus 2x squared when you transpose, which also implies when you divide by 2, x squared is going to be equal to 9. Therefore, x is going to be plus or minus 3. But now q is on the positive x-axis. We can say, therefore, x at q is a plus 3. Therefore, q is the point 3 and 0. So we know that now we've got a value for x there. Okay, great. So this is very nice. It's very easy, straightforward. Of course, some subheadings do assist to explain why you are substituting a 0, because there is a substitution that is a 0, and essentially getting these solutions is important, and essentially picking out that value at q is the ultimate. Okay, so we've got 6.1.3. let's move, guys. 6.1.3 says given that x equals 4,5 at s. So now we know that this is 4,5. all right, and some y value which we don't care about at the moment. Determine the coordinates of r. So how do we do that? Look, remember, this is the axis of symmetry, basically, meaning it is the point between the two x-intercepts. So we've got a 3, we've got an x. So this means this distance here to r should be the same as that distance to q, because that is the average that is the average. So meaning the x-coordinate at S is the average between the x-coordinate at Q and R. And the corresponding y value, because it's an x-intercept, is going to be 0. Nice and easy. So a determination is by inspection or by calculation. Here we're going to use both. So we can say R is the point where x at R plus x at Q over 2 will give us the x at S and 0. Okay, so this is important. So this implies that our R is like this. X at R is what we want, plus x at Q is 3 over 2 is equal to 4,5 and 0. So the gymnastics here is to cross multiply that and then transpose that 3. So we can make a conclusion that therefore R is, now this is 4,5 by 2, that's 9. 9 minus 3, that's 6 and 0. So here a bit of analytical geometry stuff came into our 4. So please, knowing these kind of things is very important, guys. How many marks were we scoring? Just 2 marks. So essentially, a determination can be by inspection or whatever. So in my opinion, I would say these substitutions here are important in the final answer. That's how we score those 2 marks. Okay, so let's do 6.1.4. Now this says determine the value or values of x for which g double prime of x is greater than 0. Okay, so now let's look at the equation of g. Now we know that g of x is that hypothetical stuff, which is ax squared plus bx plus c. Now we know that when we take the first derivative, we know that g prime of x is going to be 2ax plus b, because c is a constant, so it's out. Great. Now we know that the second derivative of g is going to be basically 2a. But since a is greater than 0, how do we know? Because of the function is concave up. So it therefore means our g double prime of x is always greater than 0. It's a positive answer. And now to answer this question, if this is always positive, graphically, the function would be a horizontal line. Okay? So if we're to put this on the Cartesian plane, we know that this function would be something like that. So that is g double prime of x. Okay, because it's always positive, we can see that. So it takes only positive y values. But now we're supposed to find the values of x for which this is the case. We can see this takes any x value actually. From negative infinity to positive infinity, this thing becomes positive. So we can say therefore x must be an element of all real numbers. That's how we answer this question. So essentially, working things out a bit, again you can see here we just had to rely on algebraic manipulations. So this is very important. So for me, it is key to suggest this, and essentially this argument leading up to this argument is key as well. So I don't know, or you can get just 2 marks for the answer, because remember, when they say determine, you can do it by inspection and you can leave out all of this argument. But I'm putting it out there so that you can understand how things work together. Okay, great. So let's do 6.2. So 6.2 says the function is defined by, again we're getting a hypothetical function, has the following properties. Okay, now that's great because it will help us to understand what's going on. The domain is an element of real numbers. Okay, we know that the domain of a hyperbolic function is an element of real numbers, but with a restriction if it is shifted about. And the restriction is that x is not equal to minus 2. So what does that mean? This means x is equal to minus 2 is an asymptote. And which type of an asymptote is a vertical asymptote? Okay, so this is already saying that we've got an asymptote at x is equal to minus 2. Now, what does this suggest about our graph? It means our y is now a over. Now, when we put it back, we put it to just transpose this to this side. It's going to be x plus 2 plus q. So we are moving. So this is giving us an indication about our graph of y. Okay, let's move on. Let's continue analyzing. We're told here y equals x plus 6 is an axis of symmetry. Can you see an axis of symmetry? This one, if you look at it, it's the one with the positive gradient because x is positive. So how do we interpret this? So we know that essentially axis of symmetry is given by y with the positive gradient is going to be x minus p plus q. So this is basically x plus 2 plus q, right? Right. So this means this is x plus 2 plus q. So can you see here what we can strike as a balance? We can see that this equation has a constant term of a plus 6. So this means this situation is equal to 6. So 2 plus q is equal to 6. Therefore, q, when you transpose there, it becomes a 4. So we've got our asymptote. So it goes again to suggest that, okay, we are moving. Y is equal to a over x plus 2 plus 4. So and then we are told here, the last bullet, is that the function is increasing for all x element of real numbers except our asymptote. So now if this is increasing, it means a is greater than a. Wait. It means a is less than 0, right? So meaning that a value is a negative number, whatever it is. Because you know when a is less than 0, the graph is in the fourth quadrant and first quadrant. So as you can see, these graphs are climbing as you read them from left to right. Okay, great. So now we understand what we are dealing with. Maybe this is too small for one to see. So this characteristic is suggesting that our graph is something like this. This is y, this is x, it's going to be in the fourth quadrant and second quadrant and fourth quadrant. And as you can see, when we read from left to right, these graphs are increasing, okay, indefinitely. So now we've made our analysis, guys. It's very great to do that. So it says now sketch a neat graph of this function. Your sketch must include the asymptotes, if any. Can you see they are pretending as if you won't find them? They know they've given to you indirectly, so you have to work them up. Okay, so let's start here. We were given y is equal to a over, now we've got x plus p plus q. Now, we know that since, now with x should not be equal to minus 2. it is such that y is a over x plus 2, right? Plus q. This is what this means, because we've got an asymptote at x is equal to minus 2, so it means it must be a plus 2 inside. And then again also, what do we know? We know that with y equals x plus 6 as an axis of symmetry, we know that essentially it is such that, and with a positive gradient, right? Axis of symmetry with a positive gradient m. It is such that we know that y is equal to x minus p plus q, which means we've got x plus 2. You just put it as it is there, plus q. Then we get that bracket off as it is effectively of 2 plus q. So we know that this means this situation is equal to 6. We can say, therefore, we can safely say 2 plus q must be equal to 6. Therefore, q is equal to 4. Yay, when. So we can say, therefore, y is basically a over x plus 2 plus 4. So you are just pouring your reasoning now, because for us to do the sketch we need to show a lot. Okay, because they say show all your workings. You get me? Now the next thing, we know that if y is an increasing function for x element of real numbers, with the exception that x is not equal to minus 2, it suggests that a is less than 0. Great. That is what is important. Then we can draw the sketch. Let's do that. Okay, so there's my grid. So if a is greater than 0, we know that the graph looks stuff like this. Okay. Of course, here you cannot put too much detail, but you just want to show your reasoning here. So essentially, we've got an asymptote at x is equal to minus 2. So we put it down there. Of course, this one may not be exactly accurate. So you see, it's a bit challenging. So let's do it with this one. Asymptotes we show with broken lines. So this is at minus 2. The next one is at 4, so we can draw it here. Alright, so this question was a tricky question. So again, we know that this is happening at 4. So we've shown it. Now, we need to draw the graph. So how does this graph look? We know that this graph is here because of the a value, or the characteristics of a. It's doing that. But now, we have a situation. Where do we draw the next one? Do we draw it here or there? Because we know we're going to have a y-intercept. Is it here? Is it there? Is it there? Is it there? We don't know. So now what we need to do is to do things to our graph. So let's have a look. Now we just need to look at this graph nicely. Now, yeah, it actually is all like. Now let's look for the x-intercept here. So x-intercept means 0 is equal to a over x plus 2 plus 4. Then we've got minus 4 is equal to a over x plus 2. So this is over 1. We cross multiply. What do we get? Minus 4x minus 8 is equal to a. Now we've got a situation here where we have minus 4x is equal to a plus 8. But remember, a is a negative number, so we don't know the size of a. So this is a negative number against a positive number whose value we cannot determine for sure. Okay, so now we have a bit of a situation, I can tell you. So now we need to know, is this a easy to solve? I don't know. At this point, it doesn't look like it. Okay? It just doesn't look like it. But let's divide. What do we do here? Let's sort it out. Now we divide by -4. So we're going to have x is equal to, this is a negative number, divide by -4, plus 8 over -4. So this is going to be basically a positive a over 4 minus 2. All right, so now this is still elusive. I cannot be so sure. If this was positive, it would be so nice, because we would know where we are going. But now I am not too sure where we are, so this is going to be a bit difficult to handle. So our x-intercept, but what do we do here? What do we do? Because now a was initially negative, so when you divide by negative, this whole thing becomes positive. But for me, this is a fraction. So a fraction is unlikely to be greater than this. So chances are it's going to be a negative answer. So again, here you're not too sure, but you're just going to assume that this is whole going to be a negative thing. Because this is a fraction, so most likely it's not going to be positive. I mean, it's not going to be bigger than that value. So we can say, look, this thing is cutting on the negative x-axis. Y-intercept, same story. When we want y-intercept, so we know that y is going to be a over 0, because now this x becomes 0 plus 2 plus 4. So again, a negative divided by a positive is going to be a negative a over 2 plus 4. Again, since this is a ratio and this is 4, it's most likely not going to be bigger than 4. So probably it's going to be a positive. Again, here we're just guessing now, guys. It's not so easy. So we can see that this one is doing stuff like this. This one is doing stuff like that. So this is the best way to sketch this. So you need to use a bit of logic here. It's not so easy, eh? It's not so easy, but yeah. We're getting a few ideas. You can see here this thing is long. It takes a bit of time. So I suppose here the marks is the shapes of the graph, showing these asymptotes and their actual values, working them out is important. And any one of these intercepts, I guess this is acceptable. But because we don't know for sure here, one could easily put these ones down here. I think you would not be punished because this is a sketch that is incomplete. At this point, I'm not too sure if we are at liberty to tell what is going on, because if they gave us an indication at least of the size and say, for example, give us a domain in which a is, say a is less than this but greater than that, we would be able to tell that as much as it is negative, if we know the range of a, we could easily work these ones most accurately, but we don't have that luxury. But either way, we get our 4 marks and we smile on. So we're taking these 12 marks. Again, this question is a higher grade question. So it's a higher order question. It is one of those questions that are there to irritate you because you've got to think deeper than just, go with the flow. Okay, bafowethu, let's move on. Question 7. What do we have? So question 7, we are told here the graph of f shows the book value. Can you see that? Of a vehicle years after, the book value of a vehicle X, okay, years after the time Joe bought it. Okay, so what is that? Of a vehicle X years, X years. So that X goes with the years, ne? It's X years. All right, great. Now, let's look at this graph. What do we see here? We can see that, well, we've got some value there, the y-intercept. This is probably the present value, right? Because that is what it costs today, perhaps. Then years later, as we can see, on the x-axis we've got years. So that is the years. That is 4. So 4 years later, it costs this much. So it depreciated. But now, is this a straight line? Let's test it out. It's not a straight line. So this is actually hyperbolic or parabolic, however you want to look at it, or exponential. But it's a decreasing function. So this is basically using the reducing balance method of depreciation. So that is very fancy, no? This is nice. And then we're told the graph of G shows the cost price of a similar new vehicle years later. So that is an appreciation this time. Of course, this is a new vehicle that appreciates from this value, okay? All right, so again, is this a straight line? Let's put it to the test. It's not. So you can see this is exponential. So this is basically just compound. So appreciation is basically using the compound method. So this is now appreciation using compound interest. Okay, great. So that is essentially the things that we need to do. And we can see that the time is still 4 years. So A is basically a question. How much is this? So we're going to use that to get that. So I've never seen this question asked in such a nice way. This is the power of creativity by the examiners. This was excellent. Anyway, let's go for it. Okay, bafowethu. So I'm getting a lot of distractions so far. I'm trying to do work at the same time do this tutorial. So you will see that I'm losing a bit of time. Now let's go for it. 7.1 says, how much did Joe pay for? Is it Joey? It's not Joe, it's actually Joey. How much did Joey pay for the vehicle? That man. That is the amount of money. So this is 450,000 rands. Easy one mark. 7.2 says, use the reducing balance method. Can you see we already identified it, to calculate the percentage annual rate of depreciation of the vehicle that Joe bought. So this one depreciated to this amount. So we know that the formula is A equals P into 1 minus I to the exponent n. Still financial maths, but it's coming in a very strange way. So this is 736,90 equals the present value, which is 450,000 into 1 minus, this is what we're looking for. Now the exponent is 4 because that is 4 years. Okay, great. This implies that we've got 243,736,90 divided by 450,000 is equal to 1 minus I to the exponent 4. So what we need to do now is to take the fourth root to get rid of this fourth root right here. So what you do on the left, you must do on the right. So this implies, so let's put it onto the calculator basically. Shift that, taking the fourth root of 243,736,90 over 450 squared. So this gives us a 0.8579 to 4 decimal places is equal to this. Just simply takes out all of that shenanigan. So therefore our I, we transpose I to that side, it becomes positive, and this value is going to be 1 minus 0.8579. Then we multiply this by 100% because it has to be a percentage. So we're going to just take 1 from that and multiply by 100%. So this is going to give us 14.21%. Okay, so that is it. Nice and easy. It's a grade 11 thing. It's a grade 11 thing. So we're getting 4 marks for this. So we're getting this mark. Maybe knowing that we're going to have to multiply by 100 is important. And here, correct substitutions essentially is important. And maybe this gymnastic. Maybe. We're not essentially testing your algebraic manipulations though. But yeah, whatever. I don't know how these 4 marks are scored. Maybe 3 marks would have been better. Anyway, 7.3. We are told here the average rate of price increase is 8.1% per annum. Calculate the A value. So that's easy. Again, we know that A is equal to P into 1. This time, that was an appreciation. That's the formula we need. This implies that the appreciated value is just A. P is 450,000 into 1 plus I. Now this is 81, so this is 0.081. Okay, this is per annum, so it's over a year. Now to the exponent 4, because it's also 4 years, ne? And then we just simply get that value. 450,000 into 1 plus 0.081. Ne? To the exponent 4. Mark 450,123 into 1 plus this is 0.081. All of that to the exponent 4. So this is basically 614,490.66 cents. Okay, all right, okay. So that's quite a lot of money. Hey, okay, so that is it, guys. So we're getting 3 marks here. Essentially, these substitutions and the answer is essentially 2 marks in my opinion. I don't know, but maybe for this, percentage manipulating it, but we're not testing that ability here. But yeah, whatever. You can check the formal guidelines for a more appropriate way of the mark allocation. So nice and easy. This is still grade 11. Now a vehicle that costs 450,000 rands, that is the one Joey has, it costs that amount now, is replaced at the end of 4 years. Can you see, same time period? Now the old vehicle will be used as a trade-in. Okay, that means it pays a portion of this, or is a deposit. Now we're told a sinking fund is created to cover the replacement of, so the replacement cost of this vehicle. So that means when we trade it in, we'll be trading it in at this amount right there. And then, yet this one will be costing that amount over there, right? Right, so the sinking fund is going to be for the difference, right? Now I told you the payments are made at the end of each month, so that's fine. Now the first payment will be made at the end of the 13th month, okay? And the last payment will be made at the end of the 48th month. That is exactly at the end of those 4 years. And then the sinking fund earns interest at 6.2% per annum compounded monthly. Okay, so that's fine. So we know that, okay, we've got to do our timeline. But we've got to be smart about our timeline. T48, this is the end of 4 years. And then we are paying at the end of the 13th term. So we're paying an X amount here. Okay. T0, we don't have anything because we're not paying. We are not paying. So we are doing this at 6.2% per annum compounded. Monthly. Okay. So our timeline is just sorted. But now, what do we know of it? We know that the future value here is going to be X into, because here we're looking for the monthly payment, is going to be equal to X1 doing 1 plus I to the exponent n minus 1 all over essentially I. Okay, great. So let's move. This implies, what would be this future value? So what we want, this is our value of the sinking fund. So the value of the sinking fund is going to be the difference of these two. So it's going to be basically 614,490,66 minus this amount that we're going to be able to pay when our car depreciates. So 243,736,90. Okay, that is essentially what our sinking fund is going to be. So this is 1 plus I, this is going to be 6,2 divided by 8,000, it's 0,062 over 12, because this is monthly. Now we need to know, what is this time period? How many payments are these? So we're going to take the last payment and subtract this one, and then add 1 because there's already an extra payment. So n here is going to be basically 48 minus 13 plus 1. This gives us what? 48 minus 13 plus 1, that's 36. Okay, great. Because there's an extra payment that we're putting down on term 13. So this is going to be to the exponent 36. This is minus 1. All of that over 0,062 divided by 12. Now here we're performing the gymnastics, so we can say therefore X is going to go, take this and cross multiply this. So this is 614,490, 0.66 minus 243 736 comma 90. Then we're multiplying by this interest rate 0.062 over 12. Okay, all of this divided by the big bracket, which is 1, plus 0.062 over 12, all to the exponent 36 minus 1. Okay, so let's see. This is going to be in rands. So it's a very big calculation. So 614,490 614,490 comma 66 minus 243,736 comma 90, that we're multiplying by 0.062 over 12. So here the key is just a correct substitution and manipulation. Otherwise this thing can be easy. Okay, so let's deal with this situation. This is all raised to the exponent 36 minus 1. My calculator is almost screaming. So I'm getting 9,397 rands 11 cents. Okay, it's quite a lot of money, almost losing 10 scored for 36 months. That is 3 years. Yeah, that's quite a lot. Anyway, they skipped quite a lot of time. So this is essentially that calculation of a future value that you often get in grade 12. So this is a grade 12 question. It's not a grade 11 anymore. And it was a bit nice. So how do we get these marks? Calculating the sinking fund value is important, and getting the period was important, and the general substitutions 3 marks, and the final answer is a mark. And probably working that interest like that is where the 5th mark is. And we're taking 13 marks, and we run with it and not look back. Okay, so that was an easy situation right there, but a pretty interesting way of depicting it, calling a comprehensive approach, because yeah, that was quite comprehensive and very fun. Okay, let's get to 8.1 without wasting time. 8.1, we are given f of x is equal to x squared minus 3x. And then we're told we need to find the first derivative using the first principles. So this means that f prime of x is going to be f of x plus h. Okay, that is wrong. I'm jumping the gun. This is equal to the limit as h tends to 0 of Sir Isaac Newton's quotient. Now that is good. That is good. So this is equal to the limit as h tends to 0. Now we substitute things. So when we see x, we put x plus h, and then we square that minus 3 into x plus h, minus we put our f of x is x squared minus 3x all over h. Okay, great. This is the limit as h tends to 0. Now we do this one, we FOIL it out. So this is going to be x squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x over h. Now if you guys will do the things that can be done, talking of breaking the English into pieces, Why not? We have to. We have to break that English because it is not our mother tongue. Unfortunately, it's a very useful language currently. So we've got 2xh plus h squared minus 3h all over h. Okay, so we still continue with our limit as our h tends to 0. Now we do something here. We take out h as the common factor. We remain with 2x plus h minus 3 minus 3 ne? Yes, all over h. Now these guys do that, they simplify to 1, and then we can drop the limit here. We've got 2x plus 0. Now this is where you substitute for h minus 3. This is 2x minus 3. So that is the answer. So we can make our conclusion that our f prime of x is that. Of course, using the power rule, this is basically 2x minus 3. So we know we've done it. I'm not even going to say where are the marks. It is inconsequential. All right, 8.2.1. So we're given here y is equal to, we are given here x squared minus 1 over x squared, all of that squared. So let's simplify this. First, this is x squared minus, we take this into the numerator, so this is going to be x to the minus 2 all squared. And then we FOIL it out, so this is going to be x to the exponent 4. This times that is going to be x, same basis, we simply add the exponents, it becomes 0. So x to the exponent 0 is 1. Ne? So we've got minus 1 here. Now this times 2 is going to be minus 2 because this is twice. And then we take this one, it's going to be plus x to the exponent minus 4, right? Right. And then we can say, therefore, our dy over dx is going to be 4x, constant is, it falls away, minus 4x to the exponent minus 5. If you like, in grade 11, we don't allow people to leave powers with negative exponents. So we can say this is 4 over x to the exponent 5. And that should be the answer. But of course, don't torture yourself. You can leave it there. It is still okay. So obviously, sorting this into this format is a mark, and doing those derivatives is excellent or brilliant. So that is how those 3 marks are scored. Move winner. And then we've got 8.2.2. This says we are looking for the derivative in terms of x of this situation. So this is x cubed minus 1 divided by x minus 1. So this implies that we've got dx of, now this is a difference of 2 cubes because 1 cubed is 1. So how do we factorize that? It's going to be x minus 1 into x squared. Then we know we can do this by inspection. So we must multiply this by what? By plus 1 to get a minus 1. Now the middle terms are both 0. So how do we get 0? This means we must have minus x squared plus x squared. So this means here we must just put plus x. So you need to be quick. You need to be quick, guys. So this is x minus 1. So this one cancels that. Then we can do our dx. Maybe let's first see that we are doing dx of x squared plus x plus 1. This is going to be equal to 2x plus 1. That's the answer. Can you see? So you're dropping those brackets in the dx, and you are putting an equal sign, not that implied sign. Okay. Maybe let's just drop it like this, so that it looks right. This is equal to 2x plus 1. Just using the power rule there. Nice and easy. So essentially simplifying this to that is important, and those derivatives is the extra marks. So 11 marks in the back. So this is usually nice. There's nothing to lose there, unless you're not careful. So let's go to question 9. Question 9, what are we doing? We are given the function h of x. Again, it's a hypothetical one, but with a bit of extras. So we can see that the coefficient of x cubed is negative. So this means our a is less than 0. Okay. If a is less than 0, it means on a Cartesian plane, our function looks stuff like this. We don't really care. Oh yeah. We can see here there's no y-intercept, it's 0, right? Because the x term, we needed the d term, which is the constant. So it passes through the origin. So our sketch was a little bit closer to reality. Okay, passes through the origin. So pieces of information like this are very important to analyze, because this is key. And your sketch must always be very close to the answer. It must be very, very, very representative of what you are given. Anyway, so we're also given g of x, which is minus 12x. And what do we know here? That would be the gradient. So it's a negative gradient, so it's fine. Then we're told p and q are the turning points of h. And we can see this one is positive, so that turning point is there. So this is q, which is 2 and 10. And then the other one is p, so this is the minimum turning point. So that is p, which is x and y. We don't know what it is. Okay, great. Are the turning points of h, not a problem. The graph of h passes through the origin. We could already see it already from just the state of our equation. Now, 9.1 says show that a is 3 over 2 and b is 6. And you can see here, this is quite a walk. So what do we notice? From our sketch, we can see that point q is a point on this graph. So we can substitute that point into h. So 9.1, we know that h of x is basically minus x cubed plus ax squared plus bx. Then through point q, which is 2 and 10, it is such that 10 is equal to minus into 2 cubed plus a into 2 squared plus b into 2. This implies that 10 is equal to, this is 8, so it's going to be minus 8 plus 4a plus 2b. And of course we can make this one equation 1. So this technique, this is a higher grade question because it's indirect. You need simultaneous equations to go around it. And then we know that also, what do we know? Remember at the turning point, when x is 2, the first derivative is 0 because these are stationary points. You can see the gradients are 0. So we know that essentially h prime of x is equal to 2. Sorry, f prime of h of 2 should give us a 0. Okay, so that's fine. Now we do the derivative there. So this is going to be minus 3x. Now instead of x we put a 2, but then this is going to be squared. Plus, now we're going to have 2a Instead of x now, we're going to put a 2. And then, of course, the derivative there just leaves b is equal to 0. So I'm doing two things at once, guys. So I'm sure you understand. This implies this is going to be 4 by 3. This is minus 12 plus 4a plus b is equal to 0. Therefore, we can make b the subject of the formula. It's going to be 12 minus 4a. We can make that equation 2. Now, what do we see here? We see, without a shadow of a doubt, that we can actually say put equation 2 into 1, because equation 2 is much simpler, such that we've got 10 is equal to minus 8. I don't know why I didn't sort out those nicely. I should have sorted them nicely. So this is basically 18 is equal to 4a plus 2b. Let's sort it out so that we don't suffer. So this is 18 is equal to 4a plus 2. Instead of b, we're going to put 12 minus 4a. This implies that we've got 18 equals 4a plus, this is 24, minus 8a. Okay, great. So this implies going to transpose 24 to that side. So 24 minus 18 is 6, isn't it? So we're going to have 18 minus 24. Yes, it's minus 6. Is equal to minus 4 plus 8 is minus 4a. Therefore, a is going to be minus 6 divided by 4. This is, minus 4. This is basically 3 over 2. Okay, that's correct. Okay, so that is correct. So we got it. Therefore, we know that our b value is basically going to be 12 minus 4 into 3 over 2. And what do we know? 2 goes once, goes twice. Then 2 by that is going to be 12 minus 6. That is 6. So essentially, it's done. So here they are giving you a hard question, but they're relieving you by giving you the answers so that at least you know what is going on. Okay. So what matters here is knowing this portion of information. Again, this is application of calculus in a cubic function. So essentially, deriving that equation is important, and deriving the second equation is important. Substituting one into the other is an important technique, and algebraically solving for that is a mark, even though it's given, and then giving that substitution here, maybe. But we normally don't mark a substitution twice. So maybe we can leave that one and say, anyway, ascertaining that those values are there, we're getting the marks. So we're getting how many marks? 5. Yeah, that's good. That's good. So I think this one is a bit vague, but yeah, whatever. These marks can be anyway. From this substitution here, that substitution there, or this statement right here. So it can be anyway. So these 5 marks are in the bag anyway. So let's go. 9.2. Calculate the average gradient of h between p and q if it is given that x is equal to minus 1 at p. That's great. So let's see. P is the point minus 1 is 2. Now we substitute this into the original equation because it's a turning point of the equation. So we know that this is basically going to be minus into minus 1 cubed plus we know a is 3 over 2, x is minus 1, we're squaring it, b was 6, and then this is minus 1. Okay, so therefore point P is minus 1 is 2. So we need to find those coordinates. Minus into minus 1 cubed plus 3 over 2 into minus 1 squared plus 6 into minus 1. I'm getting a minus 7 over 2. Can you see our sketch was not really bad? It was not really bad because we can see the y value is negative and the x value is negative on that turning point. So we can say then we know that the gradient between P and Q is going to be y at Q minus y at P over x at Q minus x at P. So what is that? Anyway, y at Q is 10 minus this one, 7 over 2, all divided by, this is 2 minus into minus 1. So let's get it done. So we've got 10 minus into minus 7 over 2 divided by 2 minus into minus 1. So calculators can handle that. So this is basically 9 over 2, which is effectively 4,5. Okay. You can even leave it at 9 over 2. Still okay. That is great. So this one was nice and was easy. So how many marks there? 3 marks. So getting this point properly is important. Substituting into the formula and the answer is 3 marks. Okay. Aswakauleni swahuqa 9.4. We are told here. Hi man. 9.3. That was 9.2. Okay. 9.3 says show that the concavity changes at x is equal to a half. So obviously we know that the concavity changes at the point of inflection. So we know that concavity changes at the point of inflection. So here you are just displaying your knowledge, man. We are bonagal, but we are shisabe, such that the x coordinate at the point of inflection is going to be the average of these points, because the x coordinates of the turning points will give us an average, that is the point of inflection. So we know that it's going to be x at Q plus x at P all over 2. This is easy. X at Q was 2. This one, what did we get? Minus 1. It was minus 1 over 2. So this is basically a half. Therefore, x at the point of inflection is a half, and we can see that it is true. Okay. We're getting how many marks? 3 marks. When actually this one was 4 marks. Oh Lord, where is the extra marking? Where is it? Where is it? Maybe we can say this substitution day. It's fine. Yeah, but substitutions don't give you more than enough, man. Okay, maybe let's give you 2 marks for the answer. I don't know why 4 marks. It should have been 3 marks. This one is effectively 2 marks because the substitution and the answer is important. But maybe stating that expression, you know, 3 marks. So they're just being generous here. I don't understand why. 9.4. It says explain the significance of the change in question 9.3 with respect to h. H is a cubic function. So the point of inflection tells us about this concavity. So when we're told here explain, we are to say a few words. What are those words? We can say that, look, the graph of h is concave up when x is less than a half, which is that point there, and concave down when x is greater than a half. Can you see? Because of the shape of the graph. So that is the significance of this change. It tells us about whether the graph is concave up or concave down. So I think that is essentially what this is all about. So we're getting 1 mark for all of that shenanigan. Again, it's a pretty vague question, so please double check with the actual memo and see how they explained this, because sometimes questions as vague as this, you can still find them. Then from how they are saying it themselves, you can then learn a proper way of saying this. I don't know. But this makes sense, we accept, especially with these two expressions. They are very important. Okay. 9.5, the last question. Yeah, this question paper was long. Determine the value of x given that x is less than 0, at which the tangent of the graph is parallel to G. Okay, we know that parallel lines have equal gradients. They have equal m's. That small letter m is for gradient, right? So now what are we looking for? The x value. Now basically we are trying to find the x value where the gradient of f is equal to minus 12. And we know that that x value is negative. Obviously, where do we see negative gradients? It's either it's here, so that gradient could be there, or it could be somewhere there. But they're already telling us that instead of the positive one, this is the guy that wins, because we're being told our x value there should be negative. So let's move. So what do we know? We know, okay, for the gradient to be equal to, so we know that f prime of x is equal to minus 12. That's what we're saying here. Now, we want to work out the x value, right? Great. So what is the first derivative of h? Now we go back. I don't know, did we ever write our full equation for h? We did not. But that's not a problem. Let's see. Maybe let's do ourselves a favor and write h before we state what we're stating. Because without h of x, we're going to run into problems. This is minus x cubed plus 3 over 2x squared plus 6x. That is h. So we know that here we are suggesting that h prime of x is equal to minus 12. This is that situation. Now this implies when we take the derivative, there's going to be minus 3x squared. Multiply by 2, there's going to be plus 3x. And then plus 6 is equal to minus 12. So we can see we've got a nice quadratic coming up. Transpose the 12, it becomes 18. We isolate 0. So we work out what is this thing. So now here we can divide by minus 3. Such that we're going to have x squared minus x. then this is going to be minus 6 is equal to 0, which we then can factorize grade 10 style. Knowing how to factorize is great, guys. It's a life-saving maneuver in mathematics. Now 6 is going to be basically 3 and 2. Now to get that, this is minus 3 plus 2. Therefore, x is going to be minus 2, or x is going to be 3. Can you see, we saw that this would happen when x is a positive value and negative value. So now we can see that here, therefore, this happens when x is minus 2. That is the answer. All right. This is important. Easy 4 marks, guys. So what is important here is to note that the first derivative is going to be equated to minus 12. And doing the actual derivative is important. And essentially, getting this value, isolating that value is important. The rest is a means to an end, is it not? I suppose so. But let's just say here, for these answers, it's also important, and then selecting the correct one according to that instruction. We are sorted. And then we are taking this 17 marks, okay? Even I'm not crying nice, to be honest, except for this question 1. That would be a higher grade question. Because here you have to find your way on your own. The rest were pretty standard. They were pretty standard. But probably this one would fit a higher order question, you know. But masibe go green to show that it's not too bad, but it could scare you off a bit. But do you see, we're having a sketch to work with. Everything makes sense, guys. So don't cheat yourselves. So now we would be told we don't have time anymore. But because this is a review anyway. So if you were doing this exam, you would essentially be able to finish this before, you would spare like 30 minutes tops. You would never have time to spare more than that. Tops 20 minutes, let's say 20 to 30 minutes, maximum 30, minimum 20, you can spare with this approach I'm showing you. Because you're not talking to anybody, you're not trying to show options, you're just going for it. Okay, but again, you can explore some options to make sure you are doing the right thing. Question 10 says, a rain gauge, okay, is in a shape of a cone. Okay, cool. So that means you need to know about a cone. Now, these are things you can study just before the exam and cram them if you have to, because you will never get formulae for this. You will have to know how to get this formula. Now, we're told water flows into the gauge. So this is open, right? So now the height of the water is h when the radius is r. So we can see there's our radius r, and we've got our height h. So this is now the water inside the gauge. Okay, great. And then we're told the angle between the cone edge and the radius is 60 degrees. Okay, as shown in the diagram. So basically, this is suggesting that we'll have to consider working with that right-angled triangle at some point. So this means trigonometry is coming back. Okay, all right. All right, now it says determine r in terms of h and leave the answer in set form. Okay, not a problem. So we're going to focus on that triangle, basically 10, 1. So we know that the tangent of 60 degrees. Why am I choosing the tangent? Because I have adjacent to the angle, I've got the opposite, and it's a right angled triangle. So when I want to work with these 3, I can use 10. So 10 is basically opposite, which is h, over adjacent, which is r. Okay, But now I want r, so this is over 1. Famous gymnastic of cross multiplication will imply that our r is basically going to be h over the tangent of 60 degrees. Now this is h over, now the tangent of 60 degrees from special angles is basically square root 3. Can you see? Bit of trigonometry there, but you can even use your calculator if you don't remember, but you should know. Now, in grade 12, we don't have to rationalize the denominator. But if you are doing grade 11, you would probably not be forgiven leaving a z in the denominator. You would have to rationalize. So at some point, some of you would prefer to leave this answer as root 3 h over 3. This is when you rationalize. But you're not really forced in grade 12 to do that because we have lots of fish to fry here. So that is the mark over there. Essentially, and those substitutions. That is how those 2 marks are scored. So 10.2. We're told determine the derivative volume of water with respect to h, okay, when h is equal to 9 centimeters. Okay, great. So this is a very silly question, is it not? It's an optimization type of question. Now, how do we find the volume? Now, we've got a lot of formulas here. But if you notice, pi r squared h, this is a volume of a cylinder. A circular cylinder, basically. So this one doesn't help. This volume of length times breadth times height, this is of a rectangle, for example, or it could be a rectangle or a square. So we've got here, this is either a rectangle or a square. So now these formulae are not the ones. Now this is stuff that we need to think about. But a volume will always have a height. So this is the volume of a cone. Again, if you don't know these, at least I've done some justice to help you remember by writing them out. So this is the formula we are supposed to use, because this one doesn't have h, so essentially it does not tell us anything about a volume. We can accept that. So again, they were not trying to volunteer the formula for you. You needed to select the correct one. So the volume here, in terms of h, is going to be essentially, maybe let's not say that, the volume of a cone is going to be a third of pi and the square on the r times h. We substitute, so this is a third times pi. Now r in terms of h is basically h over the square root of 3, that is squared, times h. Okay, great. So now let's sort this out. This is basically a third, let's just not rush, times pi over 1, times this one is going to be h squared over 3 times h over 1. We want to be careful here. So now we've got ourselves here, this is going to be, this is basically pi over, this one is basically 9 h cubed. So that's the volume in terms of h. So we can say therefore the volume in terms of h, is like that. Now we're looking for the derivative of the volume. So this implies that the v prime in terms of h is going to be basically 3 times pi over 9 of h squared. This is basically pi over, these ones cancel, over 3h squared. This is basically pi over 3. Now h we are told is 9 centimeters. So basically, let's see what is that now. So we've got ourselves shift pi over 3 into 9 squared. So this gives us a 27 pi, which is essentially 84,82. General instruction, 2 decimal places, centimeters squared. Because we can see that this is 9, and when we square that, it becomes centimeters squared. So be careful. But when you substitute, you don't have to substitute a unit. But you're trying to track it. So this is the derivative in terms of h when h is 9. So we can see this gives us an area, essentially. So this gives us an area. Okay, all right, okay. So these are our 5 marks. So let's have a look at it. Okay, so getting this expression is important, the volume in terms of h. And essentially, this would be the derivative, essentially. So this is basically 3 minus 1. So basically this one, the derivative is important. The substitution is important, and the answer is important. Now, where is the extra mark? I don't know. Okay? I don't know. So, whatever. Maybe selecting the correct formula. In maths, though, you normally don't get a mark for the formula. But because it was not exactly given directly, so perhaps selecting the correct formula is your extra mark. That's being tested. But also testing your memory. Can you remember things? Yabona nina. Ibuzinto ezimnandi apha. Ama cry nice. So this was 7 marks. So normally you can lose marks here or gain marks. It's up to you. But this is an easy question because it applies calculus, but they spiced it up with a bit of trigonometry to test if you really know your maths or you don't. So bebengadlali ngo-2015 ne bebengadlali undize nani. Okay, masiqhubezele ke ngoku. Question 11. Okay. So so let's go for it. We are told here 2 events A and B. Okay, it is given that the probability of A is 0,2. The probability of B is that. And can you see the probability of A and B? This is an intersection between A and B. If it exists, we're either looking at doing the addition rule. Sorry, they may look to ask us a question on the addition rule. This is P of A or B, which is going to be P of A plus P of B minus the probability of A intersect B. So we may be asked a question like that and say, okay, maybe let's do. We can get a question like that on the addition rule. Nice and easy. Or we can be asked a question on independent events where we're testing the product rule that P of A and B is basically P of A times P of B. Okay, so these are the 2 things you can think of when you're given information like that. So guys, please explore your options well enough because there's no excuse for getting these things wrong. Now it says, are events A and B independent? Can you see? So this is what we are going for. Justify your answer with appropriate calculations. Obviously, So we can simply say to answer 11.1, let's test the product rule. So let's say P of A multiplied by P of B is going to be 0,2 times 0,63. Let's see. 0,2 times 0,63. It gives us a 0,126, which is this value right here. So what is that? This is essentially the probability of A and B. If that is the case, so we can make that conclusion. Therefore, the probability of A times the probability of B is equal to that. We can say that. And therefore, what do we say? We can say, therefore, the events A and B are independent. Zizmele equivalent. It means the other one occurring does not affect the other, even though they can coexist. Okay, all right, okay. It's like a wife and a husband, eh? Yeah, but anyway, there are some dependencies going on in there. Okay, great. So essentially, guys, this situation is important, and stating this is important. And the conclusion, maybe 3 marks is scored like that. I'm not too sure. So let's go for it. 11.2. 11.2 says the letters of the word decimal. So dealing with decimal. How many letters are here? 1, 2, 3, 4, 5, 6, 7. So we've got 7 letters. Again, this is very important. You analyze everything, guys, are randomly arranged into a new word, also consisting of these 7 letters. Okay, that's good. So the question says, how many different arrangements are possible if we are talking a repetition of the letters? Okay, all right, okay. So 11.2.1. So we know that we've got 7 letters. 1, 2, 3, 4, 5, 6, 7. Now we're repeating. So out of 7 letters, we've got 7 options for that spot, that spot, that spot, that spot, that spot, that spot, that spot. Because we can repeat these letters. And essentially we're multiplying these possibilities. So we can see that this is 7 to the exponent 7. And we need to find the value there. So 7 to the 7. This is 823,543. Of course, different arrangements. So, umempohlo wayemfundise eJongsizwe eMount Fletcher eZingonyameni in the Eastern Cape. That is a rural school. It is very close to my home. Taught me that when you answer, xa kubuza uba zingaphi iigusha ezilahlekileyo, awuzuvela uthi ziyi-4, uzawuthi ziyi-4 ziigusha ezine. So you must always say something. Isimamva sibalulekile. The suffix is important, guys. So this is important and that is important. That is how we score those 2 marks. So 11.2.3. Letters may not be repeated. If they are not repeated, we still have 7 points or spots. 1, 2, 3, 4, 5, 6, 7. So for the first one, we've got all 7 options. But if we put down 1, we remain with 6 options. We put down 2, we remain with 5 options. We put down 3, we remain with 4 options. We put down 4, we have 3 options. We put down 5, we've got 2 options. And then we're left with just 1. Okay. So when we don't have repeats, we get a factorial, because this is 7 factorial. So let's do it. What is 7 factorial? 7 factorial is 5040. Okay. Again, different arrangements. That is the stuff that we need to reconcile. Okay, all right, okay. So knowing this is a 7 factorial and getting us that value is those 2 marks. Great. So we've got 11.2.3. Now it says the arrangement says we must start with a vowel. If vowels is khamiso, A, E, O, U. So we've got 4 vowels. So how many of those vowels are in this word decimal? E, remember is khamiso is when your tongue is flat on the floor of the mouth and your lips are open, right? This is when you say those sounds with your tongue flat on your floor of the mouth and your lips are opened, they don't touch. So those are vowels. So that is E. As you can see, E, your mouth is open and your tongue is flat, right? And the next one is this one, I. As you can see, I. Can you see, even though your jaw is moving a bit, but your mouth, the lips don't touch, your tongue is I, is still flat on the floor. Okay, sengikufundisa isingesi ke manje. Ungangishayi. So that one, A, is the same thing. So those are the sounds that you make without your mouth, the lips of your mouth touching and your tongue not moving from the floor. A. You see, those are the vowels. So how many we've got here? 1, 2, 3. So we've got 3 options for vowels, ne? And end on a consonant. Consonant isn't just sitting or singing kamiso. Iba ngathi ukhamisile but awukhamisanga kwaphela. There's a lot of things happening. The lips touch, the tongue moves from the floor of the mouth. It may even touch the palate. Sithi inkalakahla. Wakho wayiva ke ngokulento. Ndiyakufundisa ke mntana esikolo. Now, what is the story there? The story is saying how many consonants. Remember, these ones are the D's. D, can you see your tongue is touching your palate, your hard palate there? C, your tongue is also touching there. M, the lips are touching. L, you know your tongue is touching your palate. So these are sing and kamis. Because when you're opening your mouth, ukamisa, your tongue is flat, your lips are open, right? But here there's a lot of movement of the tongue. So it's as if you are kamising, but you're not fully kamised. You understand? You understand now. Anyway, so those are the consonants. And how many options do we have here? It's 1, 2, 3, 4. So we've got 4 consonants in that word to make up the 7. Okay, great. So now we still have our 7 spots here. We've got 1, 2, 3, 4, 5, 6, 7. Now we're starting with the restriction. So the start is a must. It's not a should. You can, you cannot. It's a must. Now there, we've got how many vowels? We've got 3 options, but we're going to put down 1. Then we come to the next restriction, which is the end. We must end with a consonant. It's a matter of a must. How many of them? We've got 4 options for that. So once we put down 1 and 1, how many letters have we left? We've got 5. So these 5 can end up here. 4, 3, 2, 1. Why? Because there is no repetition of the letters. If we could repeat these others, well, we could do a lot of damage, but now we're not. So we're multiplying all these options. Okay. So what is that? This is 3 times, this is 5 factorial. Okay. This whole shenanigan right here is 5 factorial. Ne? And then times 4. So let's put it on the calculator and see what we get. So we've got 3 times 5 factorial times 4. This gives us 1,440 different arrangements. Okay, so that is great, Bafuetu. So this is nice. Textbook stuff, essentially. So they're giving us 4 marks. So obviously this is a mark, that is a mark, that is a mark. This is adhering to the restrictions and the answer. Great stuff. We are good. We are good. Okay, now let's do 11.3 right here. So 11.3 says we have how many T orange balls and 2 yellow balls. Eziqanda. Okay. Now once you are given these kind of things in a bag, so these ones are in the same bag. So here we're creating some kind of dependent versus independent events. So most likely a tree diagram is going to be our option here. A tree diagram is going to be our absolution, most likely. So these questions are higher grade questions using probabilities. And you have to find your way as well. So let's analyze. Okay, Craig randomly selects one ball from the bag, records his choice, and returns the ball. Can you see? If we are returning the ball, we are creating independent events. Definitely, for independent events, we can express them on a tree diagram. So that means we are doing it. He then randomly selects a second ball, records his choice, and returns it to the bag. Can you see? And how are these choices? These choices are random. So he doesn't open and look and choose. He just puts a hand inside and just draws the ball. Okay, now we're told here a very nice story that it is known that the probability that Craig selects 2 balls of the same color, the keyword is the same color, the same color, okay, is 52%. So it says now calculate how many orange balls are in the bag. As you can see, so bateke nabasebekuphila nje a bit of a relief. Now they're asking you a very smart question. So let's see. We need a tree diagram here to get around. So let's see. First of all, from the bag, we can draw a yellow ball. We can put Y, or an orange ball. We can put it as O. The second draw can either be a yellow ball, or it can also be an orange ball. The same thing could happen if we followed this pattern. This one could either be like that or like that. So understanding tree diagram is important. Now what are the thing is there? So we know that the yellow balls were 2. So we're going to have 2 divided by the total is going to be T orange balls plus 2 yellow balls. So, so the total is basically T plus 2. And since we created independent events, this is going to be still the same T plus 2. But then if this is what is happening here, okay, because we are returning these balls each time. So here orange balls is T divided by T plus 2. So this is just the same thing. So we're going to have here 2 over T plus 2 because we are returning them. So this is basically, no. Orange balls is not 2, but it's basically T of them. Oh, yavele yabambi into yesingesi. So T plus 2. And then here we've got 2 divided by T plus 2. So nothing changes here. T divided by T plus 2. So this is very important to do. If you don't do it, you're going to be dead and you cannot be salvaged. So now we're saying it is known that the probability that Craig will select 2 balls of the same color will be 52%. So basically this is the arm that we are talking about. It could be like that, or it could be like that. Can you see? So those are the arms. So it's either that arm or this one. So we can just say probability of event, meaning two of the same color, is going to be basically either the probability of yellow and yellow, or in maths is a plus, or probability of orange and orange. Okay, so now that you've set up a nice equation, this is why this is higher grade. You have to find your way around. So 52% is basically 52 over 100, which is equal to the probabilities. Now you just simply multiply. So this is 2 over t plus 2 multiplied by 2 over t plus 2 plus, on this side, this is basically going to be t over t plus 2 multiplied by t over t plus 2. Okay, great. So now that we have a nice equation, we can solve algebraically. So this is 52 over 100 is equal to, when you sort this out, it's going to be 4 over, now this is t plus 2 all squared, plus here we sort it out, it's going to be t squared over t plus 2 all squared. Okay, this also implies that we've got 52 over 100 is equal to same denominator, so we can simplify this by saying this is going to be t plus 2 all squared. This is just the knowledge of fractions, nice and easy. Now we can cross multiply here. This implies, now when we multiply that, we get 52 into t plus 2 all squared is equal to 100 into 4 plus t squared. Okay, great. What do we do then? We've got 52 into, this is t squared plus 4t plus 4 equals 100 into 4 plus t squared. Okay, great. Now we sort this out. It's going to be 52 t squared plus 52 by 4 is 208 t plus 208 is equal to, this is 400 plus 100 t squared. Okay, now we move things around, so this is bigger than that, so we rearrange. So we're going to have 100 minus 52, that is 48 t squared. Then when we transpose this t, it's going to be minus 208 t. And then we've got 400 minus 208. So 400 minus 208 is 192 is equal to 0. So we've got ourselves a quadratic. So now we have to attempt to factorize. Let's see. Does 208 divide 48? The answer is no. So it's not going to work. Now let's say 192 divided by 48 is 4. Okay. So now this is where your charisma is tested. But of course you can use your general quadratic formula. If you feel overwhelmed, you still have options. You're not forced to do this. Now let's have a look. 48 is basically 12 times 4. 12 times 4 is 48. So this is 12 times 4. Now let's look at 192. 192, we said 192 divided by 48 gives us 4. So this is 48 times 4. Will it work? Not too sure. Not too sure. These ones are not going to work because we have to multiply each one by the other. So when you say 12 by 4, we get 96. Sorry. When you say 12 times 4 here, if we're multiplying this and that, so we get 48, ne? Plus, now we've got here 48 into 4 gives us 240, so it doesn't give us the middle term. So we get minus 240. So these ones are not going to work. This is hurting me now. Iyangibulala, hayibo. This is hurting, it's hurting. How else is 48? 48, say divide by 6 is 8. So this is 6 times 8. Ne? 6 by 8. And then let's leave these ones alone and see what happens. It's not going to work. It's not going to work. Because we're going to have 48 times one of these numbers. Then that means we need to find another way of dividing 192. Let's say 192, answer, shift, fact. It gives me 2 to the exponent 6 times 3. So this is basically 2 to the exponent 6. So this is 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Aibo. 6. And then times 3. Will it work, bafowethu? Asazi sobona khona. So now we need to make some nice arrangements. We can be smart about our business and say this is 3 times 2, that is 6. Ne? 6 times 2, that is 12. So we can take this and make it 12. And then we take this and make it 8. 12 by 8 against these ones. What are we doing here? Will it work? I'm not sure. Let's say 12 times 6 is 72, ne? So 12 and 6. Okay, bafethu sengidlala imaths manje. Angisaqhubeki. 12 by 6 is 72. Then 8 by 8 will be 64, right? So this one into 8 squared, it's 136. Yeah, yasiqhela. Ayihlangani bafowethu, ayihlangani. So ngathi zosiphathisa ikhanda, masiyeke kanje. Now the next thing what we want to do is to find a common factor there and simplify. So iyafailisha lento. So the big numbers are refusing. Maybe I'm just missing something. It's fine. Before we start here, let's see. What can we divide by? Can this thing divide, say, 12? Yeah, 48 divided by 12 does. It's a 4. 208, does it divide 12? It doesn't, so it doesn't work. 48 is 16 by 3, right? Yes. So can it divide 16? Yes, 3 times. Can 208 divide 16? 13 times, okay? Can 192 divide 16? It's 12 times, so that is good. So we can divide by 16, which is the common factor here. So this is going to be 3t minus this one. 208 divided by 16 gives us 13. So this is minus 13t plus 192 divided by 48. By 16, sorry. It's 12. So this is 12 is equal to 0. Now I think we can handle this one. Ingxaki ndiyakuthanda ufactorize ke bantwana besikolo ningamangali. I could have easily used the general quadratic formula because now my head is starting to crack. So this is 3t and t. These two brackets are negative. 12 is basically 4 and 3. Ne? So this is 4 and 3 or 6 and 2. Let's start with the 6 and 2. So let's say, let me see. 12 is 4 and 3. Right. So maybe let's put 3 here and put 4 there. What is that? What is that? So 3 by 3, that's 9. 9 plus 4, that's 13. Great, so this one works. So therefore our t is going to be equal to 4 over 3, or t is equal to 3. Essentially, the number of balls cannot be a fraction. We don't have a ball and a half. So this one is not acceptable. So we can say, therefore, there are 3 balls, 3 orange balls in the bag. Okay, guys, so that is great. Okay, now we leave it here. Whether it's correct or not correct, sometimes it's overwhelming. If you have time to spare, you can check. But yeah, I'm feeling a bit dizzy already. But from this step, guys, you can just use the general quadratic formula. Don't sweat too much when you don't need to. Use all the skills that you have at your disposal. You should be fine. Okay, all right. Okay, so this is 6 marks. So obviously, this one, I'd give you 2 marks for getting the tree diagram and the probabilities thereof. Okay, number 1. Number 2, setting up this equation is important, and substituting into that equation properly is mathematical. And then we've got how many marks now? 4. So essentially, sorting up this quadratic, even though we're not testing algebraic techniques, but it's very important, and selecting that. So we've got essentially 6 marks. So however you do this, usually the final answer is not normally gonna get a mark when it is like this, but remember, these marks can be anywhere. So you just look at your formal marking guidelines. So this paper was long, guys. It was very long. So here we are taking cry nice. Okay, the last question was not so nice. 17 marks for a total of 150 if everything went according to plan, unless we've made a mistake somewhere. So if you spot any mistakes, please let me know so that I can confirm whether it's a mistake or it's deliberate. And you guys, please practice this paper as well, and then use this video as a review. And I tried my best to give you as much as possible so that you can understand essentially how this paper was constructed and what is the benefit of doing these papers during your practice, and revising as many as part of your preparation for the finals. Otherwise, losisonbize ngotaendi, hey, umbize kamnandi kakhulu, ndivele ndancibilika, because it's my mother who called me that. Only my mother. So you just brought up a very special name for someone special to me, you know. Vele ndandenza ndancibilika, ndavele ndayenza lento without delaying, even though ndingaphilanga kakuhle. I'm not really well, but yeah, I got bored from sleeping and I kind of melted because of how I was addressed and did this memorandum. Anyway, guys, see you next time. I hope you can subscribe into the channel, give this video a like. What is the point of doing that? It's first growing the channel so that it can be visible, and to this video, the more likes it gets, it becomes more visible. The intention is for it to reach other students who probably need it to also practice, to review a bit of their knowledge, and to succeed. It's not about me, it's all about you guys. So you can do this, you will be helping others as well. Okay, all right, okay. Goodbye for now. I'll see you next time.